очень просто.
Hello, everybody.
Hello.
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 Hello all. I believe we hear
Hello.
each other.
Hello.
Let's wait a couple of minutes. And organizer are doing something. Hopefully we'll finalize very shortly.
Доброе утро.
Здравствуйте.
Здрасте. Доброе утро.
Здравствуйте.
Здрасте.
Здравствуйте.
Здрасте.
Hello, guys from CSIT. Do you hear us?
Доброе утро.
Hello?
Здравствуйте.
Hello, Samuel. It seems there's a communication problem, right?
It seems right. There is a communication problem. This is the point. Just wanted to double check with the guys. But unfortunately, I don't know. Hello, guys from CSIT. Do you hear us? Hello?
Hello, Samuel. It seems there's a communication problem, right?
It seems right. There is a communication problem. This is the point. Just wanted to double check with the guys. But unfortunately, I don't know. Hello, guys from CSIT. Do you hear us? Hello?
Good morning, everybody.
Hello, Samuel. It seems there's a communication problem, right?
It seems right. There is. This is the point. Just wanted to double check with the guys. But unfortunately, I don't know. Guys from CSIT. Do you? Hello?
Good morning, everybody.
Hello, Samuel.
On behalf of we will have very interesting scientific sessions, discussions, and many other things. And we do believe that it's a good platform in order to share our knowledge, to have some fruitful discussions, and also to have new links of scientific collaboration with our partners locally in Armenia, but also abroad in the regional and also in the international level. So now, if you don't mind, I will start the opening session, and I will ask our distinguished guests in order to say some welcoming messages to our participants. And first of all, I would like to invite the advisor of the Ministry of High-Tech Industry, Dr. Aslanyan, for a brief welcome message on behalf of the Ministry of High-Tech Industry. So please, the floor of yours.
Ողջունում եմ ձեզ բարձր տեխնոլոգիական արտոնոմից կարևոր միջոցառում է, որը երկար տարիներ կրկնվում է եւ հուսով եմ այս ճյուղը Հայաստանի բարձր տեխնոլոգիական արդյունաբերության համար շատ կարևոր է եւ նախարարությունը աջակցում է ցանկացած նման միջոցառումներ եւ բոլորիդ մաղթում եմ հաջող եւ օգտակար շփումներ եւ բավական գիտական արդյունքների բարելավում։
Thank you very much. Now I would like to invite academician Alaverdyan, the head of the Division of the Mathematics and Technical Sciences of the National Academy of Sciences of Armenia, for a welcome speech. So we would prepare either in English or in Russian, because we have wider audience both from Russia and also from Europe.
Уважаемые коллеги, я всех
Это только у меня не слышно или никто не слышит?
Я тоже не слышу.
Да, это у всех.
Можем отдельный трек сделать.
Хорошая идея.
Yeah, we could have a discussion between us at some point.
Yeah, well,
Yeah,
I'm trying to call to somebody, but nobody is responding.
У меня не слышно или никто не слышит?
Вот директор Astsatryan, который играет очень большую роль для расширения связей с иностранными учеными. Большую роль играл также академик Mokatsian, член-корреспондент был сейчас Levon Aslanyan, Ну и у нас был Заславский, Маранджан, которые сделали все возможное, чтобы институт приобрел ту славу, которую институт сейчас имеет. Я от имени нашего отделения поздравляю, ну, желаю всех удач прибывших сюда ученых. Большое количество ученых приехало, и так и надо было ожидать из России. Практически все научные школы вот, по информатике представлены. Вот. Я внимательно посмотрел, и не случайно, что я сейчас выступаю по-русски, потому что огромное количество желаемых гостей из России. Мне импонирует также присутствие здесь представителей Грузии, Украины. И мы всегда дружили. Наука не любит политиканством заниматься. Наука едина. И все ученые, вне зависимости, в какой стране живут, поддерживают честные научные контакты. И эти контакты, наверное, позволят и соответствующим руководителям соответствующих стран, чтобы восстановили ту дружбу, которая была в Советском Союзе. Для меня очень приятно, что сегодня здесь присутствуют ученые из Ирана, это Персии. Я высоко ценю сотрудничество с французскими учеными. Это ученые, в частности, из университета Тулуз. Сейчас наша академия приобрела с их помощью новую компьютерную систему. Она очень мощная. И это есть результат этой дружбы. И здесь эта дружба должна продолжаться. Мне очень приятно, что здесь присутствуют представители Греции. Ну, я всех, наверное, не смогу, точно всех не знаю, но всех вас я приветствую и желаю плодотворной работы не только в научном плане, но и я хочу, чтобы вы имели возможность познакомиться с нашей Арменией, сегодняшней Арменией, находящейся в очень сложном положении, но, как видите, все это на нас не влияет. Мы, люди науки, стараемся все это оценить, воспринять и работать, потому что работая, мы достигнем всего возможного. Желаю вам успешной работы и хорошего настроения. Чтобы вы уехали из Армении, желаю еще раз побывать в нашей любимой нами стране. Спасибо. Спасибо огромное. So now I would like to ask our colleague, Professor Artyom to have a welcome speech. Artyom, he is the Deputy President of the Russian Academy of Sciences and also the Director of the Institute for System Programming. So please, Professor Avetisian, if you don't mind, to have a welcome message to our participants.
Hello, everybody. I would like to greet the participants of the conference and very short say only some words. First of all, I really want to be with you in Yerevan, but unfortunately for different reasons, pandemic and so on, I cannot join. You hear me?
Yes, we can hear you.
Great. So I know it's difficult to organize long-term conference. This conference have history. Every 2 years, a lot of people.
Interrupt you, but there is a problem with the video. We cannot see you.
Okay. But my video is work.
Yes, I see very good you.
Okay, now it's okay.
We see as well.
Okay, thank you. Please continue. I'm sorry.
Okay. So the conference with history is very important, and Armenia have computer science history too, because there was one big country, and in 2023 we will celebrate 75 years of computer science in Soviet Union and in our countries. And it's well known that Armenian was one of the 3-4 former Soviet Union republic who produce own hardware. Nairi, for example. That's why I think this is one of the reasons why you have very good computer science technologies and scientific schools. Just 2 minutes ago, we remember Grant Maranjan and other guys. And I want to say that leader of community is very important person. For me, Yuri Shoukourian, as I know, he cannot join us now too because he's COVID, yeah. So I wish help him, and he's great person for me personally, and I wish successful work with your conference. I will join maybe later, several weeks later. I will visit Armenia and hope that face-to-face meet with all of you. And we have a lot of work, challenge, technological challenge that we met. It's worldwide, it's not local, Armenia, Russian, or US, Europe. We together we have to respond for this kind of challenge. And I'm very glad that our friends from France provide a supercomputer for Armenia. Now we organized a special, as you know, a pipeline to Armenia for join our supercomputer to one big infrastructure if it will be possible. I hope that we together, based on our background, our international friendship, will work for response to this great challenge from technological point of view. It's very, very important. And this kind of conference, it's important because let us possibility discuss, share our ideas, sometimes informal, and Zoom and this kind of online meeting not let us so much possibilities, but in any case, next time I promise that I will visit and we will be together in Armenia. Thank you.
Thank you so much. So our next welcome message is from the United States by Professor Zaven, Distinguished Professor of Computer Science at the City University of New York, and our ex-staff member. So, Professor Zaven, you are here? Not yet. Okay, so in that case, we will move on to Professor Michel Dayd'e. He is the Deputy Scientific Director of the CNRS, and also he is the co-chair of our conference. So please, Professor Dayd'e, for a welcome message.
Yeah, do you hear me?
Yes, we can hear you.
So I'm very happy to see all of you. I'm very frustrated because I would prefer to be physically with you, especially after the 2 hard years you had. I'm attending the conference since 2 or 3. I believe it's a very important event for the region. It's always very interesting. And even more than that, direct contact discussions with researchers from the country of the area is something great, and I will miss that. The other event is finally the French supercomputer we donate from Toulouse should arrive at some point. I know he has been removed from our computing center in Toulouse a few months ago, so I expect he will arrive, I don't know, end of the year, beginning of the next year. And it's a great opportunity, as Aram said, for developing cooperation around this. That's all I want to say. Thank you.
Thank you very much. So, if somebody else would like to have some welcome message, for instance, academician Gurgen Khachaturian or somebody else, we will be thankful. So please, Gurgen Khachaturian. So Gurgen Khachaturian, he is one of our distinguished professors, but currently he lives in the United States, but we hope soon he will back to Armenia. So please, Professor
Good morning,
Khachaturian.
everybody. Good morning. I'm very glad to be here, to see very known faces, to be in my institute where I worked many years. Information technologies is very important topic, of course. I work in the information security area in the company near Los Angeles. And then I know how important is especially cybersecurity problems. And cryptography is one of the important remedies for cybersecurity, but still is a big problem it's still a big problem how to use cryptography for efficiently for cybersecurity. So that's traditionally at our institute we developed many areas, and most of the areas were like quite theoretical. Now working with the industry, I can understand how important is to theoretical development. They are very important, but still I wish the people working at this institute could do work which is closer to the life, not just theoretical. So I hope that this kind of meetings will help to develop these opportunities. So again, welcome everybody here, and then I wish the conference very fruitful discussions and outcome. Thank you.
Thank you very much. Thank you very much. So if you don't mind, we will move on for the next part of our opening session. And I would like to invite Professor Michel Dayd'e for a keynote presentation, and the presentation is dedicated on Exascale and AI activities in France and beyond in Europe. What's going on in Europe? It will be very interesting to see the presentation of Professor Michel Dayd'e. So please, the floor is yours.
Raj, shouldn't we play the video I sent you?
You can share your screen if you don't mind.
Okay, I can do it, but we had the connection was broken a few times. But okay, let's do it. I cannot share my screen. You have to allow me.
Just a moment. Just a moment.
Okay, it's okay.
It's okay now?
Yeah. Do you have it?
So it's nice. Please.
Is that big enough? Everybody see what's going on? Okay.
It's visible. It's okay.
So just a few words. You have known me during years as the head of Informatic Research Institute of Toulouse. Now I'm a deputy scientific director in CNRS in the Computer Science Research Institute, in charge still of high performance computing, but open research data, Europe International, and so on. I just want to say quick words about CNRS. I'm pretty sure you know it. It's more than 30,000 people, of course, including a lot of researchers. It has been built on the base of the Russian National Academy of Science in the old time. It's more than 3 billion year budget, and it's one of the largest, if not the largest, research organization in Europe. We have more than 1,000 research labs, you must know that CNRS labs regroup people from a university, from CNRS, of course, and sometimes from other research organizations such as CEA, INRIA, and this kind of people. We are doing quite a lot of technology transfer and creation of startups. We have more than 1,000 research control every year, and we create quite a lot of startups. We have more than 140 joint labs with industry. And talking about cooperation with industry, you see some of the logos of some of the main industrial partners. And the creation of startup is around 100 per year, which is not too bad. And CNRS is organized around 10 research institutes that are covering almost all the area of science, except some aspects of health. Health in France is, the research in health in France is done by INSERM, and CNRS is involved on some of the aspects. So we cover biology, chemistry, ecology, environment. Well, you see the list. And well, CNRS is quite famous with 23 Nobel Prizes and 13 field medals. So in terms of research organization, is quite a nice one. So let's go back to the main topic of the talk. We're going to have a look to high-performance computing in Europe with some of the main national and European initiatives, but also artificial intelligence. As you know, is one of the big topics since 4 or 5 last years. And I will say a few words about quantum, because there's some initiatives and it's related to high-performance computing in some way. So high-performance computing in Europe is now organized around the Euro HPC joint undertaking that is involving PRACE initiative. I think you have heard about PRACE. And the Euro HPC is in charge of establishing a world-leading hyper-connected and federating high-performance computing service and data infrastructure ecosystem that put Europe in the first row of high-performance computing. Of course, we all know it's a big challenge. So that means that Euro HPC is covering infrastructure, technology, application, services. And the budget is 7 billion euros over the 21-27 period. This money is coming from Horizon Europe, nearly 2 billion euros from the Digital European program that supports the acquisition, deployment, upgrading, and operation of the infrastructures. Also, the Federation of Supercomputing Services and the widening of HPC usage and skills, and 200 million from Connecting Europe Facility 2 that improve the connection, the interconnection of HPC resources, infrastructure, also contribute to quantum computing, interconnection with the EU data space and secure cloud infrastructures. So as a result, right now, Euro HPC is funding investment on the supercomputers at 3 levels: the petascale supercomputer, the pre-exascale supercomputer, then the exascale supercomputer. I'm gonna first talk about the petascale supercomputer. Most of these 5 petascale supercomputers are installed or being currently installed. They are funded, half of the funding is coming from EU. I'm talking about the investment and the operational cost. So you have Meluxina in Luxembourg. It's Atos Bull-Sequana supercomputer around 15 petaflops with some AMD EPIC CPUs and NVIDIA Ampere. You will see AMD and NVIDIA are doing very well. It's something new because if you remember well, a few years ago, the market was nearly divided by only Intel and NVIDIA, and there was no competitor. So the face of the world has really changed, and there's now again a competition. There's Vega in Slovenia. It's again Atos Bull-Sequana around 10 petaflop. Again, it's AMD EPIC CPUs and NVIDIA A100. Carolina in Czech Republic, that will be around 15 petaflop. It's Hewlett-Packard computer. Discoverer in Bulgaria, Atos supercomputer, that is around 6 petaflops with AMD EPIC. No GPU, the Karalyan in Portugal. And this is interesting. This is a Fujitsu Prime HC computer with an ARM partition. And this ARM partition is using, of course, A64FX processor. This is a ARM-based design processor used in Fugaku in Japan. That is the fastest supercomputer in the world right now. And another partition with AMD EPIC and NVIDIA Ampere as the GPU. So this is for the petascale supercomputer. You have understood it's something between 10 up to 20 petaflops. Pre-exascale supercomputer is an higher range of performance. You have 3 pre-exascale supercomputer will be installed. 2 are already in installation. Lumi in Finland. This is the fastest one. It's HP Hewlett-Packard, but the Cray design. If you remember well, Hewlett-Packard has bought Cray a few years ago. It's more than 500 petaflops. Again, it's AMD EPIC CPU. And what's interesting, AMD GPUs, the Instinct one. And to give you an idea, the cost is estimated around 160 million euro. Leonardo in Italy, it's Atos Bull supercomputer, more than 300 petaflop. It's Intel Ice Lake and NVIDIA Ampere. And one is to arrive in Spain. The competition on the manufacturer is still going on. So what's more interesting is to talk about the exascale supercomputer. The plan is that they should arrive by 2023 or 2024 with 2 cores. And the idea is to have a machine where the peak performance exceeds 1 exaflop, 1 billion operation per second. So that Europe be again in the competition towards the exascale with China, with Japan, and with USA. The first call for proposal should be in 2022 or 2023. We expect that Germany will answer to the call. Maybe there's going to be other competitors. The second call will arrive 6 months or 1 year after the first one for installation in 2024. Well, we anticipate. One of the competitors will be France. We are currently working on the proposal, and we may have some other competitors. Answering to the call, what does it mean? You have a host country with a host organization and a hosting center. In France, it will be CEA with a very large-scale computing center of CEA, where the Praise machine was hosted, and a consortium. The consortium will be France Research Organization, Industry, and other organization from Europe or industrial from Europe, whatever. Some of the keywords in the story in Euro HPC is that Europe is trying to push sovereign technology, greener and energy efficient high-performance computing technologies. That means that Europe wants to gain more independence from other technologies. Well, I'm sure you understand from the manufacturer, from the CPU maker, for example, in USA. So Europe wants to get some independence. Typically, we expect that the budget for buying such and operating such an exaflop supercomputer will be around 500 million euros, maybe more. It's something like that. It depends on the cost to buy a machine that is at least 1 exaflops within 1 or 2 years. So we are working on the proposal, and I'm in charge of, there are 3 tasks, and I'm in charge of coordinating nominating the one that identifies exascale applications, the application that's going to get the highest priority to run on the computer to be selected and installed in 1 or 2 years. Artificial intelligence. There's a coordinated EU plan on artificial intelligence that has been announced in 2021, and that aims at creating an EU global leadership in trustworthy AI. The idea is to strengthen Europe's leading position in the development of human-centric, sustainable, secure, inclusive, and trustworthy AI. There's funding both from Digital Europe and Horizon Europe. And the idea is to ensure that AI works for people and is a force for good in society. Europe wants to get a strategical leadership on some sectors, such as, you will not be surprised, climate, environment, health, robotics, public sectors, law enforcement, migration, asylum, smart, safe, and sustainable mobility, sustainable agriculture. Well, I mean, that I'm quite sure that you share a lot of these priorities, for example, in Armenia. The target budget is 20 billion per year from public and private investment over the following decade, which is quite an interesting budget. And there's also a new AI regulation to make sure that Europeans can trust what AI has to offer following a risk-based analysis, identifying things that are unacceptable, high risk, limited risk, minimal risk, because I'm pretty sure it's the same in your countries. People are anxious about AI. They fear some of the AI aspects. Well, maybe they've been looking at too much movies, but I think that the AI entity will lead the world instead of humans. So you have to ensure them. So an AI plan was announced by President Macron in 2018, which is called AI for Humanity. And AI is one of the big things in the CNRS objective and performance contract, what we call COPS. That's something we sign with the government every 4 or 5 years. There are 6 main research organizations in that plan. In the digital section, you have 1 point related to AI, is AI foundation, models, data, and algorithms. Also in the COP, you have 6 societal challenges identified. There are some of these about climate change, this kind of thing. And 1 challenge is dedicated to AI, just to stress the fact that AI is a very important topic, both at the European and the French level. In the national plan on AI, 4 interdisciplinary artificial intelligence institutes have been selected. And the CNRS is the only research organization in France that is partner of all the 4 institutes. There's also a national AI platform that has been deployed, and it's part of the Janzé supercomputer, which is hosted at IDRIS, CNRS National Supercomputing Center. And also there's a national network of engineers for providing support to the users. So Janzé supercomputer was the first, what we call that converge supercomputer in Europe. That converge means answering both to the HPC and AI needs. So that means on that platform, you have a partition devoted to HPC and a partition devoted to AI, but in fact, they look the same. We have some nodes for AI, maybe with a higher memory size. We have also some nodes that have 8 GPUs instead of 4 GPUs, but basically the same architecture. And what's very interesting, Janzé is available since 2019, and now we have more projects in AI than in high performance computing, even if there's less users. But AI is growing extremely fast, and this is a kind of amazing thing, because we didn't expect such a fast growth in the needs of AI on the French national supercomputers. I think this success is due to two things. The support, the very good support we are providing to the AI users, that for some of them, they are not totally used to high-performance computing platforms. And we have provided what we call dynamical accesses. What does it mean? That means if you want to compute on Janze, you go on the web, you fill a form, and 2 days after, you have an account. While for traditional HPC computing, there were 2 calls a year where you have to apply and to get a few millions hours. So this is very important. And in the Computer Science Research Institute in CNRS, called INS2I, of course, scientific priorities reflect that strong interest to AI, because we have some team working on foundation of AI, trustworthy and responsible AI, privacy, reliability, fairness, bias, robotics and AI, interaction with human, new computing paradigm with some careful look at green aspects, shaping new application fields, and something very important within CNRS is strengthening the interdisciplinary collaboration with people from all the other research institutes. So if I have a look practically, what does it mean? We have one national supercomputing center in CNRS, already mentioned, is Idris that hosts Janze. Janze is more than 2,000, nearly 2,700 V100 NVIDIA GPUs, and that makes the performance, and the performance is 28 petaflops, sorry. It's a Cascade Lake processor. There's a very high amount of memory and more than 65 petabytes of disk. And the reason is that people are doing AI, but on a large amount of money, on a large amount of data. So they need this fast disk access and a huge amount of disk storage. Also, between Idris and the computing center of IN2P3 on the right, there's a joint project for providing computing resources and storage resources to what we call the large-scale research infrastructure in France and Europe. That means that we try to answer to the needs of synchrotrons, telescopes, all these instruments that produce very large amount of money and require a lot of processing power. So CCI2P3 is a computing center. IN2P3 is a research institute in CNRS in charge of nuclear and particle physics, and is involved in a high number of international projects, such as the LHC in CERN, and it's one of the largest computing center attached to LHC. It's a tier 1 of the WLGC grid that you know, because we have been a node of that grid. With more than 20,000 cores and more than 43 petabytes of disk. I'm sure the numbers are wrong because it's increasing every day. And very quickly, in that picture, I'm trying to show you the interest of all the other research institutes in CNRS in terms of HPC, also high performance data analysis, what we call HPDA, and artificial intelligence. We have some discussions on intensifying, strengthening our collaboration between institutes on AI, for example. Into people dealing with the science of universe, of course, they are doing large-scale simulation, but they also have to process data coming from instruments, observational data, or from other source. INP, for example, they are involved in a lot of synchrotron, so producing a lot of data and requiring more and more processing power. INE is the Environment Institute. They have a lot of databases, center of synthesis, etc. They are involved in a lot of projects. So processing data, analyzing data is something very important for them. INC is chemistry. Shows are doing numerical simulation, but more and more they have some interest into using AI. And like INP, the Physics Institute in CNRS. For example, they are interesting into studying new materials based on the data analysis. In CIS is Engineering Institute, again, numerical simulation, high performance data analytics. In SME, they are doing mathematics. So as us in computer science are involved in the research on high performance computing and data analysis. Biology at INSFB, well, you know, they face a data deluge. So they are already organized with a kind of national network of computing resources with some regional supercomputing center, and there are more and more involved in the use of a national supercomputing center. And social and human sciences, SHS. They have some youth project and they have a strong interest on data analysis. So that just to cover a little bit what's happening. About quantum. So recently there's been some announcement around the quantum. It's in some ways it's a whole topic because people are looking at that since quite a lot of time. And in that area, that seems very promising. Europe is pushing for sovereignty and to support some researches and some European technology. And the goal is to have a first quantum supercomputer in 2030. It's the funding of the quantum plan is included in the 8 billion of the euro HPC program for the 21-23 period. There's already have been several calls call for proposal on quantum. A quantum flagship has been launched in 2018 with 1 billion euro over 10 years. Several EU projects has been awarded. For example, one project involving Atos, CNRS, Indria, and the Pascual startup has started. I just want to say a few things about that. Atos is providing a quantum simulator with a complete programming environment since a few years. It's a simulator. And Pascual is the French startup, and they claim they are the first row of the real quantum supercomputer on the market with 100 qubits based on, this is what they claim. And this is what the people are telling me on the really stable technology that are called neutral atoms. And they say the machine has a kind of quantum accelerator that will be connected to a traditional HPC system. Not that my Japanese friends are telling me the same thing, telling me that they will start experimenting on some quantum system considered accelerated, connected to traditional high-performance computing supercomputer. So there's been a French quantum plan announced by President Macron with nearly 2 billion euros. The research action in that plan are coordinated by CNRS, EA, and INRIA, and it deals with quantum computing, of course, but also sensors and communication. And there are some issues related to cybersecurity. People from industry are also involved with Atos, already mentioned, but Thales, STM, Microelectronics, some startups, and in the startup you see Pascual. And there are 3 main initiatives that involve the CNRS currently, 2 in Paris, the Paris Center for Quantum Computing, and Quantum in Paris-Saclay University, and the Quantum Engineering Center in Grenoble. As a conclusion, well, I'm delaying time. So again, there's a very fast evolution of CPU and GPU architecture, as we observed in the past with the vector process, multiprocessor, etc., etc. So it's very rich. There's plenty of very nice things to analyze, to study, and it will be still the same for the 2 or 3 next years. Some of the issues are that first, AMD is back in the market. ARM configuration with ARM processors start to be really used and deployed, and Intel has start providing some GPUs. So it's really interesting. We know that there's a convergence on high-performance computing, high-performance data analytics, and AI. My point is that I consider that AI is nothing else than another great application area of using high-performance computing, but all scientific areas are involved in that, and they have to consider it. Quantum accelerator, they may arrive sooner than what we expect, because European plan is announced in 2030, but some of the guys are start doing experiments. So it's very, 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 very interesting. I hope I convinced you there's a very strong effort toward our exascale, AI and quantum, both at the European and at the French level, with a major initiative. And you've seen that the European level, one of the major preoccupations is to have a basic technological ecosystem that doesn't entirely depends on foreign manufacturer, to try to develop some home technologies that provide some sovereignty or independence as you want. I think I finished. I hope I haven't been too long. Thank you.
Thank you so much for a comprehensive presentation. So if you have any questions, please. No questions? Once more, thank you very much for your interesting presentation. And now we will move on for the next speaker, Professor Levon Aslanyan, who is the corresponding member of the Armenian Academy of Sciences and also the head of the Division of Discrete Mathematics of our institute. And his talk is also very interesting, especially for this COVID situation. And he's a well-known scientist, not only in Armenia, but also beyond. And also he is a quite active person in international cooperation by being a member of many international organizations or leading many international organizations and consortiums. So please, Professor Levon Aslanyan, the floor is yours. Take the mic.
Thank you. Dear colleagues, in our current pandemic situation, it's of course quite understandable that we want to address the issue of viruses. The presentation will be not only biological, not about only viruses, but also about its mathematical and computational parts. We present this presentation together with Zaven Karalyan, who is the head of laboratory for molecular biology and virology in Institute of Molecular Biology. Presentation will be in 4 parts. At the beginning, I will speak about deep biological data that's related to whole genome sequences and their collections. After that, I will bring some information about quality justification of sequences, which we call alignment. After alignment, we will address a practical problem of biology, which is phylogeny trees, which is something related to graph theoretical problems.
I'm sorry to interrupt you, Professor Aslanyan. So a few days ago, Armenian government decided to have a minute of silence today at 11 o'clock in a minute, which is dedicated to the soldiers and officers for the last war, which was started the same day a year ago. So please 1 minute of silence, and then we will continue our workshop. So thank you very much. Sorry. So please continue. Sorry to interrupt you.
So let us start with big data. Big data is a busy word today, but in my understanding, in my mind, it's related to some issues that I faced many, many years ago. My scientific advisor, Professor Zhuravlov, was developing the theory of local algorithms. In local algorithms, we have a very large structure of particles, elements, which are related to each other. Maybe we are given distances, maybe we are given links between them, maybe there are weights or something else. In those days, it was not possible to analyze very large sets of information, so this structure completely cannot be solved in one round. Because of this, he decided to consider fragments, local neighborhoods of these particles, these elements. He defined first neighborhood, second neighborhood, etc., etc. And then comes a question about integration of these fragmentary knowledges, information. Is it possible to compute some global knowledge for fragments, for local neighborhood areas? And is it possible later on to integrate all this information into one global knowledge? In my understanding, this is exactly the situation with big data. So we have a resource, we have algorithm, which can analyze some parts of information. It's very difficult to analyze the whole in one run. The problem is to solve by this way a problem, how to gain some global knowledge of this complex structure. We used we used this approach of computing big amounts of data. And in this way, we were able to solve some discrete optimization problems. Among these problems, there are reconstruction of monotone Boolean functions. Let's say this is some generic technique. We considered frequent item set generation for data mining, and also wireless sensor network self-organization problem is very close to these approaches of divide and conquer. As we will see, this idea of local algorithms will be also very fruitful for viral genomic analysis. Big data itself, independent of my supervisor and his understanding, etc. Big data, of course, came to us after the year 2000, just to try to define or to describe big data. IBM used, let's say, the 3V scheme, which is where 3V letters mention, the first one mention volume, second one velocity, and third one variety. And they want to pass by this explanation that under big data, we have to understand real large data amounts, which are coming after terabytes. Also, this data can come by flows, by streams, data streams. This is a specific structure of data. And of course, variety, which is different formats of data. Let's say data that are coming from industry, let's say in banking. They include JSON type data, XML maybe, and of course SQL type data. So this is the past and current environments for big data. Where I just wanted to say the relational database management systems and data warehouse technologies doesn't work for terabytes and much larger data. And because of this is what it was invented, Apache-based Hadoop and Spark and other some this kind of systems. But for me, it's more important the scientific big data, the big data that are coming from science, than the big data coming from industry, like banking, Internet of Things, maybe smart cities, and this kind of very heavy applications of information technologies. Here are some ciphers for big scientific data. First is large hadron collider. Something is working, something not. Okay. Is producing 1 petabyte data in 1 second. Another example is antennas of square kilometer array that they also produce 100 terabytes per second. These are very huge data amounts, and it's of course not possible this situation some years ago. Data amounts are growing and growing, and finally we approach to biology, because I just come to biology to show that also there are big data today. Excuse me. In biology, the main source of large amounts of data is related to next generation sequencing. It was in year 2003 where it was possible to code one full genome, whole genome of a human. This was after the Human Genome Project, which worked for some 10 years and spent $3 billion. After this 2003, things were changed very quickly And to prepare physical instruments based on physical knowledge, etc., that could very quickly and very cheaply to code genetic sequences. This we call next generation sequencing. Today, to have one today to code one human genome, it is much less than $1,000. So in this way, we are accumulating thousands and thousands human genomes. And because of one human genome is very, very long, it is 3.2 billion positions of nucleotides. So 3 billion, this is very, very long sequence. And having some amount of this kind of sequences, how to analyze them, this is become to be a hard mathematical problem and of course a hard computational problem. These are alternative sources of big biological data, biological pathways and restructuring schemes. So at this point, we have genomic sequences which are coded by 4 letters, A, T, C, and G. These 4-letter alphabet sequences, very long, I told 3 billion, 3.2 billion. These sequences, each of them is corresponding to one biological entity. Of course, the idea is how to compare these biological entities, and this means in mathematical level that we have to find the mechanism to compare these very long sequences. If we have 2 sequences, if we have 2 sequences, then if we consider one position of these sequences, things are very easy. There we can find some match of letters, nucleotides, of course, corresponding nucleotides. Otherwise, there can be a mismatch. Of course, mismatch will have different weight, different value, but anyway, we differentiate match and mismatch. But when you consider the whole length of sequences, it becomes very difficult to find out which position of first, second sequence will correspond to which position of the second sequence. This is on how to align, how to make them compatible, these 2 sequences. The basic idea for this kind of alignments is coming from Levin, who introduced the so-called edit distance mechanism. Edit distance means the number of minimal editing steps, minimal changes into sequences, so that they become equal to each other. Edit distance 1 step is insertion of a symbol or deletion of a symbol. Doing this, we are inserting into the sequences some dash letters, additional letter dash, And of course, dash with some letter doesn't do any conflict, but it helps to align the sequences. So similarity is the base element. How to compare biological entities having their DNA sequences, their genomic sequences. In this slide, what's important? In this slide, it's important that not the whole genome is important, but inside the genome, we have a lot of genes, and even inside the gene, there we have to separate two parts. One we name exon. Exon is the active coding part of genome, gene. And there is intron, which is not very much important. This information are given by some letters coming together. Let's say ATG. If this comes in genomic sequence, this means then there is a start of a gene, and other combinations are closing triples. We name them codons. By these codes, reading the sequence from the beginning to the end, we can analyze and find out all useful information fragments, exons. This is very much important, and we name this by structural reading. Structural reading, when we are reading from beginning to the end, marking this exon intervals. This is very much important because this helps us to add some technology to alignments. The alignment problem in its core biological problem, of course, was first time solved by biological people. At the moment, to list the basic approaches for aligning two sequences, it's to mention the dynamic programming model, the dynamic programming mathematical approach, the dot plot matrix approach, and the word methods. These are three separate technologies that are used in genomic alignments. To be useful, aligned sequences must be very close to each other. If they are not close, this will give some sophisticated, not useful output. There is some requirement about homology, similarity, high similarity of these sequences. And the tendency is to in a first step to find homologous sequences and then to align them. After alignment, we obtain some score of similarity. A score of similarity is that for match of letters, we are giving some positive value. And when there is a mismatch, we are giving some negative value, and at the end we are obtaining some similarity score for two sequences after this alignment. In this picture, you see, I mentioned it, three technologies for alignment, three current technologies. This is dot plot technique. This is visualization, very helpful. But of course, it is a manual work just to get this picture and to analyze by human So unfortunately, this is something very helpful for a biologist, but not automated. Here we see here we see in first good alignment. In second, we see alignment and reverse alignments, which is a negative case. And in third example, we doesn't see anything. So two sequences in our experiment, the first one and 19, they have no any matches, so they are not homologous. Related to similarity, there is also one more problem. This is when we have a fragment of a sequence and we want to find in a large database of sequences, we want the parts that are highly similar to the given input. In mathematical terminology, this is best match search algorithm. And I have to mention about some achievement in this area. When we were proving the proposition of Ronald Rivest from 74 about optimality of Elias algorithm for best match search, and we were proving this by discrete isoperimetric theory that we developed earlier. So two types of similarity: pairwise sequence similarity, and best match similarity. First one is for large sequences. Second one is for search in databases. Here is the picture of dynamic programming solution of alignment of two sequences. First application of dynamic programming to sequence alignment was achieved by biologists Nidelman and Wunsch. They did a global alignment, achieved time complexity of solving this problem, which is M by N. M and N are lengths of two sequences. And the whole process is occupying the same M by N and multiplied on N memory. Afterward, this was developed further by Smith and Waterman. They found local alignment technology, which is much better because this is eliminating the tails, the suffixes and prefixes of sequences. And in this way, they gain much more result because of, let's say, if I am comparing two gene sequences, then I am interested in aligning their exon parts, but not intron parts. And in this way, this algorithm is able to make an effective alignment. When I told in this slide about dynamic programming, I have to add something that in our team, we constructed an online alignment algorithm. What means online alignment? Online alignment means that we are reading the sequence from the beginning to the end. We are obtaining elements one by one, adding to the previous elements, and in this way, we are constructing the longest common subsequence. Longest common subsequence is the alignment is the counter mathematical terminology of alignment. So I want just to say that having this online alignment, reading the sequences and aligning them, we can join this with other fragment that I told about structural reading. In structural reading, we are reading and separating the important parts, the exon parts. And of course, it's possible to combine these two approaches just to one reading, and during this reading, to eliminate unnecessary parts of information and at the same time align the important part of information. This is quite important. Now, this is an input for alignment. Several sequences, of course, this is part of them. And the next one is the picture of aligned sequences by this algorithm. This is global alignment, and you see a lot of dashes inserted in this picture to get some more or less correct alignment. So only this alignment is able to show the similarity and dissimilarity of genomic sequences. Only on this base we are able to compute some distances between pairs of sequences, because of any analysis is based on this kind of things. Next is coming the phylogeny. Next is coming the evolutionary tree construction. Evolutionary trees are considered by biologists. They were using characters of biological entities. These are just physical characteristics. These are phenotypes of biological entities. The example can be some entity, have a tile. So using this type of information, they are constructing trees where biological entities are corresponding to the leaves of this tree, and after the constructing tree we have some root. The root is ancestry, and here we have split in two types of biological entities. In this kind of point we have another split, etc., etc. This is evolutionary tree by biologists. But of course, today our target is to make these trees by sequences, and by after alignment by the distances we obtain after alignment. Here we see two trees, very simple, just for example. The first one is generated by sequences, and they use parsimony principle. Parsimony means how to find the optimal, the minimal picture that corresponds to these tables. But this is discrete optimization problem, which is very, very much difficult because of the lengths of the sequences. And the next one is based on the use of these distances, similarity distances, and the graph theoretical problems approaches are very fruitful here. Let's say neighbor joining algorithm is constructing very quickly, and there is no additional problems. This is the picture for this neighbor joining algorithm, graph theoretical algorithm. It's working step by step. At the first step here in this example, we join sequence 1 with sequence 2 in some alignment. This X is their alignment. And we allocate what we have at input. We have the distances between pairs of sequences. Let's say between 2 and 6. We have these distances. We have to use these distances to make a binary bifurcation tree. Here is one step only, so that the total weight of edges is minimal. Original formula looks like this. If you want to, in one step, if you want to select points to be aligned, you have to use this formula. Of course, we found an easier formula, and this helps us to make these computations. Next slide is showing the computational infrastructure at the Institute for Informatics and Automation Problems. And we used this infrastructure in our computations. Of course, we solved not the complete problem, because the human genome is very, very much long, but the virus genomes are much shorter. They occupy approximately 200,000 positions. And at our current computers, we were able to make computations for large sets of viral whole genomes. This is quite difficult task. Here you have to select the correct mathematical model, to use the correct mathematical algorithm, and to do computations very carefully, because I told about homology. Homology is when two sequences are more or less in a high level of alignment. If not, then computer is creating very large amounts of memory information, and memory is not satisfactory, at least in our computer environment. But we could manage. We used the following. We say that if computer is not in a power to make an alignment of two sequences for some long time, we suppose that this is a missing data in distance matrix, and having the distance matrix not complete, but with some missing information, we succeeded to compose these phylogeny trees. So next to this is the fragment of the software that we developed, which is in Python. This program is integrating some standard tools for alignment. This is Muscle, Muscle W, and MUFT. This is the distance matrix. We see part of it. And finally, this is the real phylogeny tree for viruses. Probably here in this experiment we have only 20 viruses, but what's important that we have the weights of edges, which means the time duration passed from the beginning of formation of this type of biological entities when they were split into two different categories. So This is explanation. This is another. This is justification of our tree. So making many experiments, we want to come to the knowledge that the tree generated is correct. And in explanation, and this is the basic result that we achieved. Here we put a line. Totally 100 whole genome sequences of viruses. And this was very hard work computationally, because of any computational resource is limited. If you have some resource and you are able to solve some problem, then after that we will receive much more information, and of course there will be some shortage of computational resource. But anyway, at our institute we have quite good computational resource, but we are waiting for the bull computer that will come in January or February or somewhere, and then probably we can solve similar problems with human genome. Today we are not able to do this because of computational shortages. This is the wall. In conclusion, we have the same things that we used online alignment very effectively, and that we are using missing data matrices, and we are able to generate phylogeny trees having this situation. This is. Thank you.
Thank you very much for a comprehensive presentation. If you have any questions, please.
As I understand, all this mathematics about all this mathematics is about you have a big genomic data, long genomic data. You want to find how they are correlated and how they are different. Because when you say alignment, means how they are correlated. For example, sisters and brothers and cousins, maybe they are more correlated, right? Genomically.
Yes, of course.
I don't know any biology, but I think they should be correlated. But also they are different. So all this mathematics is about that.
Yes.
How that works. And then the same with for viruses, but viruses are shorter. So that's why you could solve the problem with the viruses. How it helps to solve this pandemic problem?
How long?
How it helps to solve pandemic
problem?
You can find that viruses how they are different, but how related to our life.
I think that we analyzed some 100. We analyzed some 100 viruses. Yes, in one run. Occasionally, there are no coronaviruses in that. But now, in Institute for Molecular Biology, they have a collection of coronaviruses, whole genomes of them. Of course, now we're able to similar things for them, but the technique, the principle is the same. By the way, a very strange information. You may criticize me for that information. Our people from Institute of Molecular Biology, together with colleagues from Belarus, they initiated a proposal, a research proposal, just to make a drug against coronaviruses. This seems some stupid idea, but no vaccination, just some medicine to help the people. And unfortunately, I am the member of that project. I will do mathematical part.
One short question. Short question. Will it be possible in the near or far future to build such map, such sequences of basement nucleotides in order to build or to construct very strong human brain, super brain? Thank you.
About making some brain or super brain, you know, my role is mathematical algorithms, and maybe biological people someday will decide to make such project. Then our institute will try to help. But in fact, you know, this is something not very. Of course, we are interested, but not biological people. I think that idea must come from that part.
Small thank you, Professor Aslanyan. So, thank you. So today we will have three interesting sessions on models of computation and their applications, artificial intelligence and telecommunication and networking. Because we are out of agenda, I suggest to have a 10 minutes coffee break and then to move for the next section. So the coffee break will be served on the second floor, one floor below. So 10 minutes until 11:50 to have a coffee break, and then we will start the session 11:50. I think it's okay for you. It's acceptable for you. Once more, thank you very much for your participation. And we encourage you to have very active, to have very fruitful discussions and presentations. So coffee break now. Thank you.
Раз, все, раз. Все, make. Раз, make, раз.
Hello, all. Can we start our session? Hello? 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 Are participants hearing me?
Արդեն առաջինը չէ։
Շնորհակալություն, որ ձայնը լսվում է։ Եկեք ես առաջարկում եմ սկսենք, ուղղակի չեմ կարողանում ոչ Սահակյանին, ոչ Աստsatryanին կապնվել, չեն վերցնում։ Նու մեկը չի վերցնում, մյուսը հեռախոսը անջատած է։ Ինչպես անենք, որ այդտեղից միանա ես տեսնեմ այդ էկրանը, երբ որ սկսենք այդ ժողովը։
Վերնագիրը բացենք, ես այդերով գնամ։
Sergey. Մի րոպե, հեսա միացնենք կամերան։
Այո։ Ահա, ես տեսնում եմ, դուք էլ ինձ եք տեսնում, շատ լավ։ Կարող ենք սկսել արդեն, հա։ Չեմ լսում։ Ձայն
Այս պահին սրահում մարդ չկա, խնդիրը դրանում է, երևի մի քանի րոպե սպասեք, բարձրանան։
Հանգեց դրսից իրանք ուզում են նայել ուղղակի։
Հա, հեսա կբարձրանան մի քանի հոգի, երևի կարելի է սկսել։
Շատ լավ։
Sergey, կոմոդ կարաս դինամիկ տանջատես, որ չխանգարի մեզ։
Այնտեղ Միջայլոց այդ սկզբի մասում այդպեսի բան կար, այնտեղ բավական ուժեղ էխո է, որտեղ այդ ինձ թվում է այդ կապված էր, որ այդ YouTube-ով գնում էր, ոնց որ զուգահեռ բաներ էին գնում եւ մասնակիցների մոտ շատ վատ էր լսողությունը։ Այդ մասը պետք է երևի սինխրոնի ինչ որ ձևով սինխրոնիզացնել էլի։ Հիմա
ասենք ձեր բանը, ասում եք լավ կնի օպտիմիզացիա անել եւ բաժելից։ Արդեն պասուտի սա։
Եվ որ էջերով եմ գնում առաջ է։
Սովորական գնում եք առաջ, բայց կարելի է դաժե բան անել, ասենք այսպես բարձրացնել, հա։
Այսինքն լավ ցույց
Այդ ինքը կարգավորման process-ի մեջ է։ Հա, всё։ Կարևորը դուք ստեղ անեք, մնացած участникները ամեն ինչը տեսնում են, առանց որևէ խնդիր։ Դրա մասին կարակ չմտածեք։ Ցելոն, այսպես կգնա։ Հա, սա ինչ չունի։
Վլադիմիր, ես արդեն գտա բանին, Ռոբերտի հետ կապնվեցի, ես ուզում էի սենք, չէի իմանում ում հետ կապնեմ, բայց արդեն ամեն ինչ նորմալ է։ Ես հիմա կփորձեմ համոզել, որ հնարավորինս ոչ թե 20 րոպե անենք, այլ 15, որ վերջացնենք էլի ժամանակ։ Հա։ Եղավ տենց անենք, եղավ, մերսի։
Այդ կոմպյուտերը վիդուշի կոմպյուտերն է, հա, ով ասեցի։ Հա, վիդուշին դրսից է, հա, всё, լավ, հասկացա։ Պարոն Շուկուրյան, ինչ որ կարիքը լինի, դուք ամիջապես ասեք, ում միացնել ձայնը, ում միացնել պրեզենտացիան, պատասխանատուն նստած է հիմա եւ ինքը բոլոր հարցերում կարա օգնի այդ պահին։
Շատ լավ։ Ես այն ժամանակ եթե ուրեմն, չգիտեմ, մասնակիցները ներկա են թե էլի փաստորեն ես տեսնում
Երևի մի քանի րոպե էլ սպասեք, որտեղ մի քիչ ուշ ավարտեցին, բոլորը հիմա դուրս են եկել, հնարավոր է կորիդորում կանգնեցին, կոֆե են խմում եւ այլն, երևի հեսա կբարձրանան վերև հավանաբար։
Շատ լավ, ուղղակի ժամանակի տեսակետից, հա։ Ես տեսա, որ պարոն Մոկացյանը այդտեղ է, եթե խնդրեինք, որ այդպես 20 րոպե է ճիշտ է նախատեսված գումարային ամեն մասնակցի համար Այսինքն մոտ արապես 15 րոպե զեկուցումն է եւ 5 րոպե հարցերը։ Եթե կարող ենք այդ 15 րոպեն անենք, ասենք 10-12 րոպե, շատ այդպես կարևոր կլինի, որտեղ ժամանակը կշահենք, կփոխենք, այդպես կհավաքվի եւ կարողանանք մեր այդ բացը բաց թողնել, որտեղ ավտոմատ այդ շեղումը ժամանակի աստելու է նաև հաջորդող սեսիաների։
Սամվել Կիմովիչ երբ կհամարեք, որ անհրաժեշտ է սկսել։
Եթե այնտեղ գոնե 1-2 հոգի կան, եկեք սկսենք, մինչև մյուսները կմոտենան։ Ինչեմ, պարոն Մոկացյան։
Այո։
Ինչ լեզվով է, անգլերեն, ռուսերեն։
Անգլերեն անենք ինձ թվում է, որ հետո որևէ այդպիսի խնդրեմ չլինի, առավել ևս զեկույցներն են պատրաստված անգլերեն։ Please, so we are starting our session. The first presenter is Dr. Mokatsian. Please.
Ասմիկ կարելի է, ստեղ չգիտեմ ինչի, չի գնում առաջ,
Ինչ չի գնում։
առաջ էջ պետք է գնում,
Հա, հեսա։ Մեկ վարկյան միացում։
Ուրեմն այդ գնալ դժվար կլինի,
Վարկյան այս մեկրիչի կամպյուտերը։ Չէ, այստեղով, այսպես ենք կարող եք իջնել, կամ կարող եք այստեղից այս լակը որ կա, ասենք իջնել։ Միգուցե հենց լակով ենք իջնել մեկ վարկյան։ Հա, այս ամեն ներքև վերև սակով։
Գնա, հա։ Good afternoon. As I have enough time, I can not be limited to list only definitions and results, but touch on content of some important notions.
I am very sorry to interrupt you. Just there is some box which is like oh now it's okay. It disappeared. Good, very good. Now it is clear. Your presentation is seen to everybody. Let's go ahead.
As we see from the title of article, it's about the notions of T-mitotic and wtt-mitotic sets. And for perception of these notions, we need to have a definitions of Turing reducibility and wtt reducibility. One of way to define the notion of T-reducibility is by definition of modified Turing machine. Now we see the description of modified Turing machine, the machine with the extra tape. You see this machine. See the description of this machine. As we see, the contrast to the ordinary Turing machine the behavior of modified machine to the contrast of ordinary machine is determined by the three factors. First factor is the internal state of machine after the previous step. Second factor is the condition of observed cell on the work tape. As we see, we have in the modified machine work tape and oracle tape. And the third factor is the condition of observed cell on the oracle tape. In the case of ordinary machine, we use only two factors. Two first mentioned factors. This is the principal distinction of the modified machine. Now we see the explanation of the motion of function, a partial computable function, where A is the oracle set. Now, we have the.
You are not. Are you able to continue?
Yes, I continue. In this case, we see that in this case we see we have the computable function which allow us estimate the quantity of the oracle integers which are used in the computation of required function on the required input. Of course, the wtt reducibility is the particular case of Turing reducibility as the other reducibilities. However, this reducibility is reducibility closest to the Turing reducibility. Is most similar to Turing reducibility. Table reducibility. Now we see the definition of the Turing reducibilities. Note that the term of computable function we use as the synonym of the recursive function. We see the definitions of the notion of T degree and wt degree in the below part of this showing. In the below part, we see the definition of Turing-mitotic set and the definition of wtt-mitotic set. Now we see the definition of important notion, the definition of notion of contiguous degree. As we see, we know that each contiguous degree, by definition, doesn't contain Turing-mitotic sets, which are not wtt-mitotic. Now about some results, well-known results. Lardner proved the existence of completely mitotic degree. That is, he proved the existence of degree which consisting only of mitotic degrees, mitotic sets. Another important result. Hrachya proved the density of non-mitotic sets. That is, he proved that the existence, he proved that between any two sets A and B, such that A less than B by Turing reducibility, there is a set C, which is between these two sets A and B. Now about our theorem, we see that for any non-computable enumerable degree B, there is a degree A with mentioned property. Note that it is well known that for any non-computable enumerable degree below any non-computable enumerable degree, there is another non-computable enumerable degree. So, by our theorem, below this new degree, there is a degree with above mentioned property. That's all.
Okay.
Thank you for attention.
Thank you very much for the presentation. Any questions? Sorry?
Some relation to application, but can you mention this?
How it is related to applications?
These results are very theoretical results, but
we have some vision how it can be useful.
In this theory, we search the
I'm sorry, I missed your voice. I'm not sure that everybody is hearing you. Hello? Now it's
our possibilities to research some process, and we by this theory we can find that some process and prove that they are computable processes. But by otherwise, we can find that there are the processes which are not computable. We have proved that there are cannot be computable. It is the practical result that we prove that it is not sensible to find the algorithms for proving this for proving the computability of these processes because there are not computable. These results are proved mathematically. It is
okay.
This is in these cases, it is very practical.
Okay, thank you for the question and for the answer. Let's move forward. Any other questions? I would like just to ask, if possible.
Hello. May I ask some questions?
Yes, please go ahead.
Just to ask, this is a right situation to ask this question. Maybe to Arsen, maybe to the session, I don't know. Is there any change of this kind of theories, computability or not computability, etc., when we are speaking about quantum computers? Is there any change? Principal change of these theories, or
so the question is addressed to Mokatsian.
So the question is basically to you.
Let's do the follow. I believe I can express my opinion related to this, but as we have some plan to pass through the session to finish, if you allow me, if we will have time, I can respond to that. I believe that there is, briefly, if to respond to your question, I believe that there is a sense to consider such kind of stuff, because theory of computability is a basis of our science, like of computer science, and it is clear and everybody accepts that. And this is some result. And related to it, may I ask you, Mokatsian, to show the publications which with the previous results and what you covered? You were referring to some previous publications, right? The last slide of your presentation. Can we have a look at it? Verci slide чувствую. Verci игра сам. Okay.
I hope you see this.
So your results are stronger than. Could you just clarify where were received last result? You were referring that for some people.
Some results I referring.
Yes. But because there were just numbers, so we're not aware of these publications. Can you say now, using this list, so what you did more than was done before you? What is done? Which result is
Ah.
which you covered. I believe you have received some stronger results than there were before you, right? Before your result.
Before my result, I indicated some results. I can say that about the result, Ladner of Sasso, about the contiguous degrees. It is very important result, and they show that there are many infinite class of contiguous degrees, and these degrees does not contain T-mitotic sets, which are not wtt-mitotic. And my result shows that there are how are distributed the degrees which contain such sets. And
from
one result is complemented another result.
What gives this distribution? What could be like easier to do if I have if I know this distribution? Could you please explain? So this you have shown that how this the distribution, right? You said right now. So and how it might be like useful for further research, for researchers who are basing on your result, what it will give them.
By their results, it is important that there are degrees which are not the property which have the sets which I research. And as there are sets degrees which have such property, and there are degrees which have not these properties, appear the question, how are distributed first type degrees and second type degrees. Some classification is implicated from their result, and some classification is implicated from my theorem. One result is complemented another decide, but there are many other questions which are open.
Okay.
There are many open.
Okay. Thank you. I believe that,
open questions in this area.
Okay. Thank you. This is I suggest to stop the discussion because we are we need to continue to be in time with the session. So please, the next presentation. Go ahead with the next presentation. The next presentation is the group of authors, Poghosyans, right? And please go ahead. Who is the presenter?
Yeah.
Hello?
Yeah. Can you allow me to share my screen?
Yeah, sure. Okay.
Can you hear me and see my screen?
Yes, we see. Please go ahead and Mr. Hayrapetyan, please take into account that we have maximum 15 minutes, but we would appreciate, if possible, to provide the presentation in 12 minutes, something like this. Okay.
Yeah. Okay.
Please go ahead.
I'm Davit, a junior researcher at the Department of Models of Computers, Logical Reasoning and Automated Theory. The current scientific direction is self-organized network models and applications. The subject of my talk today is algorithms for operating self-organizing swarms of UAVs, implementing full exchange of information. I'm co-author of the paper. I contributed in creating animations and videos illustrating the implementation of algorithms adapted for the purpose. This work was supported by the Area Science Committee in the frame of this research project. The grant program was Artificial Intelligence and Data Science. The topic was Software System for Implementing Fault-Tolerant Surveillance and Target Tasks, Performance of Collective Artificial Intelligence and Self-Organized Swarm of Drones. Research scope and objectives. The article is devoted to the introduction of methods and appropriate algorithms aimed at information full exchange in self-organized swarms of logically linked UAVs, a scientific approach to enable surveilled areas dynamic snapshotting and full exchange of captured images during the swarm quasi-random walk. Are given in terms of our relevant terms and results obtained in this direction. Besides, our methods and algorithms for constructing optimal and fault-tolerant schemes have been evolved and adapted accordingly, creating premises for operating decentralized and self-organized forms of logically linked UAVs, a strong authentication of the swarm UAVs, also mechanism for secure and reliable data transfer based on proven principles of threshold cryptography are accordingly presented. I'm shortly presenting the router model for a given graph, particularly for a given square lattice and arbitrary outgoing edge incident to some vertex is assigned a direction and arrow. This is router. In case a vertex on graph is activated and this happens when a UAV appears there, the arrow rotates. And as a result of this rotation, the UAV moves to this direction and reaches the newly marked vertex. This is a rotor. Now we have proved that in case of cycleless graph, UAV launched at some edge point on the square lattice will visit all the edges, forming an Eulerian cycle, and at the end, we'll return to our starting vertex. Also, all the arrows on the lattice will restore all initial directions. Let's watch the first video. There we can see the example. Provided the first phase of the algorithm, all the cycles on the lattice are detected and dismissed. Let's watch the second video. According to our results obtained, all the UAVs together launched at different edge vertices perform the same task like a single UAV. The order of UAV flights, also timeframes, are not important. Mathematical methods for implementation, full exchange between the swarm UAVs, relevant graphs, decentralized fault-tolerant optimal schemes, and communication algorithms have been introduced and approved. Now I am shortly presenting the non-formal description of the gossip problem. There is a group of N participants, each of which poses some piece of information subject to transfer to the other participant. Each of the N participants wish to possess the whole information through telephone calls. During each call, information is exchanged between two participants which communicate to all information known at the point of time. This problem can be mapped to a weighted graph where vertices stand for participants and the weights present the point of time the phone call took place. Gossip schemes are characterized by the number of calls, channels, and time ticks. Principal problem with gossiping is promote schemes providing minimal number of calls and time while implementing the information full exchange between the UAVs. Another problem is the fault tolerance of the scheme implementing gossip. This is a generalization of the classical gossip problem, and here we cover failures of up to K number of calls. No information is exchanged during failure. Papers written by the research team present graphs with the required optimal characteristics configured accordingly, particularly these graphs. Let's watch the last video. In this video, nodal graph implementing information full exchange is selected. The images exchanged are then integrated with the OpenDrawingMap open source package. As a result, 2- and 3-dimensional image of the surveilled area is obtained. For data transfer security, cryptographic algorithms and secret sharing schemes of proven security have been suggested. Thank you. Thank you for listening.
Thank you. Thank you for the presentation. I have a question. If any questions, I'm sorry. I was on mute probably, and my question was missed, my initial question. So I was asking whether somebody has questions to the presentation. I have one question. I'll wait questions from participants and then will ask myself. Please go ahead with the question, if any. No questions. See, the notion of swarms of UAVs is not new, right? And there are a lot of surveys, and especially last surveys, I have noticed that they are of 2020, and they are mentioning all the problems you are considering. So I believe the researchers should mention at least these approaches and then show what is like better in his approach. I didn't notice about that in your presentation. You didn't notice that something is made better than was suggested because the problems you listed are considered and were considered in many other presentations, in many other papers on the topic, right? And so I was not able to find out these modern new papers in your paper in your presentation. Could you please clarify that part? Were you able to even simple search using like Google engine, right? And brings to that, and of course a lot more you can receive if do the search using specialized engines like IEEE Explore, engines in ACM, etc. So the question is how you are justifying that your solution is unique or is better than existing solutions.
Thank you for your question and comments. Our approach is based on the self-organized.
Yeah, just to I'm sorry, just to I mean also self-organized. There are a lot of papers on self-organized. I can, for example, I can probably I can share my screen and show just a second. I'll try to open that paper. It is I'm using my home computer and probably not all is here available, but I believe that something should be available. Just give me a second. I'll share the screen.
We applied the router model. Yeah. And there is no centralized management of the swarm. There is no centralized communication.
Okay, just give me a second. Do you see the screen?
Yes.
Did you have a chance to read this paper?
No.
It is like published in 2020. And this is a review of all the results relating to the swarm intelligence and also including self-organizing systems. There are a lot of references and references for using like last publications of last years, made in last years. Okay, clear to me. Just wanted to double check with you. Any other questions, please? Okay, if no questions, thank you.
Suren Poghosyan, Hayrapetyan tetar synchron tarkmami.
Եթե կարող ենք
Եթե ստեղ քանի որ երիտասարդները համակարգում ամենակարևոր մասերից մեկն են հետազոտել եւ ծրագրավորել, ես որպես ղեկավար ուղղության ես կարող եմ ամենը հետո ասեմ, այդ հոդվածը ես ծանոթ եմ, ես շատ էլի հոդվածներ մի քանի տասնյակ նայել եմ, ամբողջ դրանում որ չկա ղեկավարման սկզբունք, չկա ոչ մի ղեկավար, արբանյակային կապ, ոչ մի բան, երամը ինքնակազմակերպող է եւ կարևորը որ ինքը երբ որ ռոտոր մոդելը օգտագործում է, ածում է էլերանցիկը, այսինքն բոլոր տերիտորիաները նկարվում են մեկ անգամ։ Դրա համար այն նկարողությունից է տրվում տանկի նկարները նենց են նկարած բոլոր տեղից, որ իրար հետ համադրելով հնարավոր է նույն 3D պատկերը կառուցել։ Ոչ մի ինֆորմացիա չի կրտում եւ կարևոր ֆակտորը որ եթե նույնիսկ վթարը տեղ ունեն կամ ինչ-որ արգելքներ կան, որոնք ինֆորմացիան չեն թողում ասել, վթարականային սխեմաները թույլ են տալիս այդ կորուստը չզգալ։ Երամը չի զգում, որ ինչ-որ մեկը վնասվել է կամ ինչ-որ մեկի կապը պակաս է։ Ի վերջո աշխատանքի ընթացքում կապը արտադրվում վթարականության լրիվ ինֆորմացիան բոլորի մոտ հավաքում։ Եվ կարևոր է, նույնիսկ եթե անդամ է վնասում, նորից եմ ակրկնում, ոչ մի արբանյակային կապ, ոչ մի վերգետնյա կապ չի օգտվում ինքը։ Իրանք աշխատում են միայն երամի իրար հետ։ Նույնիսկ երամի մասնակից տեղակ չի, երամի մեջ քանի հոգի է մասնակցել, վթարված են, թե կան, թե չկա։ Այս ամբողջը գնում է նույն արգելքները լրիվ կառուցված են այդ ինքնակազմակերպման բանի վրա, որ իրանք գնում են ռեկուրենտ վիճակների տակ։
Պարոն Poghosyan, շնորհակալություն մեկնաբանության համար։ Ես իմ կողմից նշեմ, որ ես ընդամենը տեսա, ուրեմն այնտեղ կար ինքնակազմակերպում բառերը եւ այո, եւ ղեկավարման տեսակետից էլ կար, կարծես թե ոչ միայն այդ հոդվածում, նաեւ մի քանի էլի ուրիշ հոդվածներ ես նոր հիմա ինչքան կարողացա ուրեմն նայեցի, ինձ թվաց, որ ուրեմն բոլոր դեպքերում սրանք վերջի հոդվածներն են, եթե նույնիսկ ձեր արդյունքը, ասենք, գերազանցում է եղած արդյունքները, երևի կոռեկտ է, որ քանի որ իրենք տպագրվել են ձեզնից առաջ, պարզապես նշել, որ այստեղ ինչ որ մի բան թերի է կամ ես ինչքան պատկերացնում եմ, հետազոտման սկզբունքն է այդպես, ես պարտավոր եմ նշել աշխատանքները, որոնք ինձնից առաջ արվել են, եթե իրանք թերի են կամ բան են, ես ընդամենը դա էի ուզում ասել, որ բնական բան կա, ձեզնից առաջ են եղել այդ աշխատանքները, եթե նույնիսկ ձեր աշխատանքը գերազանցում է այդ եղածները եւ ինչ որ հարց իրենք չեն դիտարկել, դուք եք դիտարկում, այդ հստակությունն էր ինձ պետք է, որ այդ հստակությունը գրվի եւ դա էի ուզում ընդամենը ասել։
Շնորհակալություն, ուղղակի հոդվածի մեջ, զեկույցի հոդվածի մեջ համատական անալիզ մի 10 հատ հոդվածի տարված է։ Այստեղ ուղղակի ելույթի ժամանակ չի նշվել։
Չէ, գիտեմ, բայց ասենք օրինակ կան ես ինչքան պատկերացրեցի, ես նայեցի նախապես, այնտեղ ասենք այդ աշխատանքները կարծես 2016-ով թե 17-ով սահմանափակվում են, հիմա չեմ հիշում ասել, բայց ասենք ես վերջի տարիների աշխատանքները ոնց որ չկան։ Ես դա էի ասում, որ եթե վերջի պետք է օրենքով, ես հիմա մի բան ներկայացնում եմ, պետք է ծածկի այդ եղած աշխատանքները։ Կարելի է գրել, որ ասենք, կամ պետք է գրել, որ գիտեք ինչ, մենք վերլուծությունը կատարել ենք մինչև այս թվի աշխատանքներ։ Այդքանն ենք կարողացել անել, դա էլ է տարբերակ, բայց բոլոր դեպքերում ընդամենը իմ ասածը հետևյալն էր, որ նույն ոլորտը, նույն ինքնակազմակերպման մոտեցումներով լուծումներ են առաջարկված եւ առաջարկված են 19 թվականին, 20 թվականին եւ բնական է, որ իրենք պետք է նույնիսկ եթե իրենք թերի են, նույնիսկ եթե իրենք ասենք ինչ որ հարցեր չեն դիտարկում, պետք է դա նշվի, իմ ասածը ընդամենը դա է։ Եղավ, շնորհակալություն ժամանակ, ուրեմն ես առաջարկում եմ, որ անցնենք հաջորդ զեկուցմանը։ We are moving to the next presentation, please. I believe it is the same group of authors.
Hello. Would you please provide me access for sharing my screen?
Sure.
Hello, I am Agit Atashyan, a junior researcher at the Department of Models of Computations, Logical Reasoning and Automata Theory. The current scientific direction is self-organized network models and applications. The subject of my talk today is certain models for investigating epidemics and preventing the spread of viruses in self-organized systems. I'm a co-author of the paper. I contributed in creating animations and video illustrations in the implementing of algorithms and adapted for the purpose. The research objectives are investigating and control of epidemic phenomena, introduction of methods of preventing the spread of viruses, promotion of newer methods of modeling the dynamics of epidemics in self-organized systems based on cellular automata, introduction of methods and approaches for behavioral analysis of epidemic waves, development of newer methods for statistical data processing, recovery for causality of in multi-level graph simulating epidemics situation observed over time, enabling collective observation and operation of dynamic processes, selection of suitable cryptography algorithms and data anonymization techniques of proven security to protect personal information at all levels of data acquisition, storage, transfer, and processing. Selection of synthetic data generation enabling simulation and investigation of the spread of viruses. The related work scope contains the following works: description of the evaluation of epidemic with involvement of self-organizing criticality models has already been provided by many researchers. In particular, in the first paper, the idea criticality was promoted to describe the occurrence, the spread of viruses outbreaks, also the virus aggressiveness and the critical value of the virus density on the population are estimated. Mathematical models of self-organizing criticality is presented in the second paper. Here the authors purposed new approaches to predict the spread of viruses by presenting the nature of the spread by mathematical function, which can be successfully used to measure localized infection energy. In contrast to classical approaches, where the severity of infection is traditionally calculated depending on population, the authors obtained the mapping of the place where the infection was confirmed. The authors also interpret the model under investigation as a cellular automata implementing a two-threshold self-organized criticality. In the third paper, the authors clearly state the applicability to of certain phenomena investigation theory to the research and modeling of the dynamics of epidemic spreading among the real population. The work number for substantiation the applicability of the self-organizing complex systems properties in the field of epidemiology. The self-organizing criticality is self-organizing organization is the process of spontaneous generation of an internal order due to local interaction between system components. The process, task places spontaneous, is characterized by the rules of dynamics, the internal states of the systems, and is not controlled by an external or internal regularity factor. Recurrent states are acceptable for arbitrary state, while moving the laws of stochastic dynamics over time, the overall system falls into set of the recurrent state which the system does not leave. Here I would like to present the one little animation to fully understand the methods and logic of working the send file model. I'm sorry, I need to share my full screen. Did you see my screen now?
Yes, we see.
Okay. In this animation, you can see the logic of working send file model. When the number of sends on the cell on one cell of the network become more than the number of neighbors of the selected cell, sends fall apart, and one send is added to each neighboring cell. And if there is no neighbor, the send simply falls. You are see the falling process. And also one of the previous works on the topic of the studying send file models is certain creation of the 2D and 3D viewer. I will share the also one video. Viewer to study the schema of modeling on the three-dimensional cube. But this implementation has some drawbacks, and main one of which is not use of the it used only internal network to connect the several users to study the models. And in video you are seeing the utility working flow. I will go ahead to save your time. Here you can see the working flow for two separate viewers or separate researchers who want to analyze the dynamic process. But all this work was going only on internal network. So this is one of the main problems of this solution. To overcome the problems, a newly created multi-user software platform and has been developed and deployed, enabling by remote connection. Okay.
Okay.
Here you can see the architecture that in this diagram. Basic concepts of the universal multi-user platform are illustrated. The platform comprises two independent components. The first component is the platform itself based on TCP/IP server and separate helpers. This is the master server part. And the second component is the client environment. The architecture and the appropriate UML diagram of the overall systems is as follows. omitted the implementation of the self-organizing behavior of the spread of the viruses in the scope of the paper. A pattern of the serious game has been deployed and developed. The game's servers are a suitable platform for conducting visual control and learning of the self-organizing criticality models. Required statistical data provided, the game software platform can be extended and adapted accordingly to enable detecting and controlling real epidemic waves. Deployment of the multi-user platform for studying dynamic processes in the cloud and on the supercomputer allows state and medical authorities to gain authentic access to epidemiology data about newly infects, recovers of self-isolated patients, monitoring the full control of epidemic spreads of the viruses will be visualized by performing served areas. Here also I would like to share some little videos. On this video, you can see the user interface for this serious game. And this is basic interface for that one. And to save time, I have skipped some parts of and some details. Just here we can see the gaming part. Okay. And here the provided the approaches for personal information protection. Okay. And thank you for listening. If you have any questions,
okay,
please.
thank you. Thank you for the presentation. Any questions? No question. Again, the same. I would say.
Yeah.
Like, any questions?
Yeah. I have one question.
Please go ahead with the question.
Please say the main three important features which characterize the self-organizing complex systems. And if you can, please bring some example from biology or human biology of such systems.
Okay. Do you hear the question? I'm applying to Atashyan. Hello?
Sorry, as you can see here, the self-organizing or self-organization criticality definition was presented here. May I have talked? No. So, if you want, I can read for you.
Yes,
again.
thank you. And if you can bring some examples from biology or human biology, human organism.
For example, the for example, the swarms of the animals are the one of the example of the self-organizing systems. The climate changes also earthquakes and the financial markets also. I think this is all.
Thank you.
Okay, any other questions? I have a quick question. If possible, could you please explain why are you considering COVID? So is it, I was not able to catch the specifics of COVID in your presentation. I mean, changes like gen-related changes or other kind of stuff.
Just, Mr. Shoukourian, just we have started development of these scenarios due to COVID pandemic. So we have just named it COVID-19.
But it is not too much relating to COVID, right? It is rather
this is in general it is related because
but not to COVID specific. I haven't seen any specific like properties or like rules, restrictions which are relating to COVID. It is I believe something like a general
we have just tried to simulate the pandemic situation, and as COVID-19 also one of the pandemics, we are for this case, for example, just
to clarify the question and to shorten. See, there is epidemic and there is pandemic. So you show what are the differences in your model. It is reflected that it is a pandemic, not epidemic, right? I was not able to catch.
As you can see, our pictures in our images, we have saved some numbers. In some of cases, the numbers are 2, 3, or 4. If number is 3, then the dead person who are simulated are contactor person, and when we are user try to infect one of the simulatable objects, in this case human. That human will make the contactor their neighbors, and their neighbors indexes, or I don't know how to clarify this part. And each contactor person who will have 2 neighbors who are infected, he will automatically transfer to the infected phase. And the COVID situation, this is one of case of COVID situation, because due to COVID-19, we have the medics have some cases when the one COVID patient infect 2 or 3 neighbors or the related persons. This is a small relation, but in general, just we have named it COVID-19 connected with pandemic situation.
I'm very sorry. I would like just to ask the question in Armenian because it seems that the presenter didn't catch what I was asking. Ես գիտեք ինչ էի հարցնում, ես ասում եի, որ էպիդեմիա եւ պանդեմիայի միջև տարբերություններ կա։ Այն մոդելը, որ դուք դիտարկում եք, այդպես ես չտեսա, ինչով է սա, ասենք, այդ էպիդեմիայից տարբերվում։ Օրինակ, ասենք, սովորական գրիպի էպիդեմիան, ասենք, որ լինում է, էլի, այդ նույն բաները ոնց որ աշխատում են։ Եվ այստեղ իսկ այստեղ մի քիչ ուրիշ սիտուացիա է, պանդեմիա է եւ նաեւ ուրիշ մոտեցումներ էլ կան այդ ինքը վիրուսը ուրեմն եւ համապատասխան ուրեմն ներբությունները կապված են նաեւ գենային կառուցվածքի հետ եւ այդպիսի բան կա որ էլի չտեսա այդ տարբերությունները դրա համար էի հարցնում մի խոսքով այդ հարցը
Կներեք պարոն Շուկուրյան ես երևի չկարողացա ամբողջությամբ բացատրել
որովհետեւ մեկ վարքյան ես հարցս չվերջացեցի եթե դուք նայեք այդ համաշխարհային կազմակերպություն առողջապահության կազմակերպության բանում այնտեղ սայթում կա այդպիսի ենթաբան որտեղ նկարագրված են այդպիսի տարբեր մոդելներ որոնք որ առաջարկում են այդ էպիդեմիաների տարածման եւ այլը մասնավորապես Ուրեմն այսինքն այդպիսի աշխատանքներ նույնպես արվում են եւ այնտեղ մի սայթ է բոլոր այդ աշխատանքները հավաքվում են այդ սայթում շատ հետ ես ժամանակի ուղակի բանից այդ սայթը չկարողացա նայել երևի դուք արդեն նայել եք էլի այդ տեսակետից նույնպես հետաքրքիր էր նայել որովհետեւ ես նկատեցի որ ձեր գրականության ցանկում հիմնականում հղումներ կան միայն ձեր աշխատանքների վրա այնինչ բավականին շատ են այդպիսի մոդելավորող ուրեմն աշխատանքներ խորհուրդ կտայի էլի այդ մասով ուշադիր նայել որովհետև եթե մենք հետո պետք է հարց դնենք տպագրության ասենք աշխատանքի ավելի լայն շրջանակների համար ցանկալի կլիներ որ այդ վերլուծությունը արված լիներ սա այդպիսի
Շնորհակալություն պարոն Շուկուրյան հետագայում անպայման նկատի կունենանք
Այո ես եմ շնորհակալ մենք
շարժ այդ համակարգի այդ բազմաօգտատեր համակարգի ինտերնետով աշխատելու հնարավորություն ունեցող համակարգի հնարավոր կիրառություններից մեկն էր ուղղակի
Հասկանալի է ուղղակի միշտ այդպիսի վտանգ կա որ ասենք գրում եք COVID ուրեմն այդպես մարդիկ կարծում են որ սա կարելի է կիրառել COVID-ին ընդհանրապես
խաղի համար COVID-ի հենց պանդեմիայի տեսնում ենք սկսել գրելը
ես հասկանում եմ դա ես լավ հիշում եմ իմ մայրս մանկաբույժ էր եւ շատ լավ եմ հիշում այդ դեպքը որ շատ լավ մաթեմատիկներ փորձեցին ուրեմն ինչ որ ձևով կառուցել մոդել եւ կանխատեսել երեխաների մոտ սրտի առատը եւ այդպիսի մոդելի վրա պարզվեց որ 50% նորածինների ունեն սրտի առատ եթե ուղղակիորեն կիրառում էին եւ մայրս ամեն անգամ այդպես բարկանալով ասում էր թե ես ինչ խայտարակություն է գալիս են առողջ երեխա է սիրտի որևէ բան չկա բայց այդպես այդ հետազոտությունների արդյունքում ասել են մեծ է հավանականությունը սրտի առատի պետք է շատ զգույշ լինել բժշկության հետ էլ այդպես մի անգամից COVID-ին անցնել իմ կարծիքով բարդ է դժվար գործ է շնորհակալություն բոլոր դեպքերում եղավ ուրեմն մենք անցնում ենք հաջորդ ներկայացմանը we are moving to the next presentation please Ներողություն, ես մյուտի վրա եի կներեք։ We are moving to the next presentation. I'm sorry. Հաջորդ ներկայացնողը, ինչ է։ Davit Թուսիկյան եւ այլն։ Davit Ալեքսանյան, Լիլի Թուսիկյան։ Չկա ներկայացնամ, այստեղ չեն ներկա։ Ալո։
Սենյակում չեն, պարոն Շուկուրյան։
Եվ շնորհակալություն, փաստորեն այն ժամանակ մենք ինչ անենք, բաց թողենք երևի այս ներկայացումը, անցնենք հաջորդին, հա։
Այո։
Շատ լավ, ինչեմ հաջորդը։ Հայք, ձեր ձայնը չի լսվում, ինձ թվում է, հա։
Sorry, do you hear me?
Yeah, now we hear you. Okay.
Thank you. Sorry for late, we have technical problems. I'm Aslanyan and I will present our work, a method to evaluate binary code comparison tools. Basically, binary code comparison tools compare two versions of program and we determine similarities and differences between two versions of program. We can determine that this function matches to other function, function to matches to other function, etc. Comparison can be done in different levels. Some tools do it in level of functions. For instance, they only say that this function matches to other function, and that's all. Other tools say that also basic block information. They show that from first version, which basic blocks matches to other basic blocks from second version of program. And also it can be done in instruction level. In this work, we created a method to evaluate binary code comparison tools. This task to compare two binaries is very challenging because compilation process can remove significant information. Binaries cannot, sometimes, and in real world, they usually don't have debug information. They can have some obfuscation. Also, they can be compiled with different compilers, different optimizations, and for different operating systems. And also sometimes they stripped and they don't have, so what I mean, saying stripped, that they don't have debug information and also information about symbols. So these things makes difficult to compare binaries, but they are widely spread and used for several aims. For instance, they use for bug search, for searching malicious program. They use to analyze patches and detect what is changed between versions. They use to find old libraries in programs, and also they can be used to determine copyright infringements. There are several tools which compare two versions of binaries: BCC, BinDiff, Diaphora, BinHash, etc. But we will consider first three because only first three has working program. Their tools are available and we can compare only first three. Others has articles, and we have done a comparison in level of algorithm, but not in level of tools. So in this work, I will present only results of first three tools using our method. So we develop a method to evaluate binary code comparison tools. As there is no benchmarks to evaluate these tools, we thought that it's necessary, and we proposed other form of benchmark. We proposed a method which can use everyone to evaluate such tools. We proposed a testing system scheme which consists of three main stages. At first stage, we generate tests. We automatically generate tests which are etалons, which binary code comparison tools should find. So they are the best results that can reach binary code comparison tools. So we generate such tests at the first stage. At the second stage, we run binary code comparison tools on such tests. And at the third stage, we evaluate metrics for these tools. We use three measures of evaluation: precision, recall, and F1 score. Precision, we compute using this formula: true positive results count divided to true positive plus false positive count. Recall is true positive count divided to true positive count plus false negative count. And F1 score is like a middle of these two metrics. It's 2 times precision times recall divided to precision plus recall. So in the first stage of our scheme, we generate automatic tests. So what is the basic idea? We choose some open source project, compile it with compilers. So we choose 2 versions of the same project, compile with compilers. It can be the same compiler or different compiler, or same compiler with different flags. So compiler 1 and compiler 2 can be different. Then we got binary of first program, a first version, and binary of a second version with debug information. This is important. And when we have debug information, it's very easy task to find match-it functions between binaries. It's very easy. We only match their names. So matching their names, we get two match-it pairs of functions. And ideally, binary code comparison tools should find exactly these matches, not more and not less. At the second stage, we use result of first stage, so binaries of first version and second version, and pass them to binary code comparison tool. But before passing, we strip second version of binary. Why? So we strip it because when we have debug information, it's very easy to determine, also for binary code comparison tools. So, but in real world, main binaries are stripped, and this step is for coming near to real world tasks. So after stripping, we pass binary of first version and binary of second version without debug information to binary code comparison tool, and we got results after that. Also, we save information of second binary stripped version and not stripped version function matches using their addresses. The third stage is a combination of results. From first stage, we have two matched pairs of functions. From the second stage, we have function pairs which determine binary code comparison tools, and also function pairs between original and stripped binaries. And then we combine these three information to get precision, recall, and F1 score. So the last part are results. We evaluated three tools: binary code, BCC, BinDiff, and Diaphora. I should mention that BinDiff is developed in Dynamics, which Google bought recently. We evaluated tools on Corutils 8.30 package. It has 105 programs, basic programs in Linux. So when we compile first version of binary and second version of binary with same compiler, with same optimizations, then we get similar results. All tools have similar precision, 98.8% to 98.3%. So it, but mainly they have similar result. We compiled them using Silang, G++, etc., with different optimization levels. But recall sucks for Diaphora and really. So for BCC and BinDiff, it remains 98% in average, but for Diaphora, it sucks and is less than 75%. So we can see F1 score for three tools, and also we measured with different versions of program. When first version of program is different from second version of program, we can see that results when we compile almost similar versions, 8.29 and 8.30, they are good enough. But when we have far versions of programs, for instance 7.6 and 8.13, then results go less. and in average we have 72% for BCC, 62% for BINDIF, but results for diaphora is quite good, 92.5%. The same for other optimization flags. When we see a recall for different versions of programs, we can see that diaphora really sucks, and it matches very few count of functions. Its precision is very high, but it matches very little count of functions. That's why its recall is very less. And in average, F1 score is the least for diaphora. Second place is BINDIF, and first place is BCC. We evaluated it also for other cases when we compile with different compilers. For instance, when first version of program is compiled with GCC 0 and second version is compiled with CLang 0. In such cases, we have 92% in average for BCC, 88% for BINDIF, and diaphora is about 55%. And also basically the same is when we compile programs with different optimization of compilers. So in average, our testing system shows that in average BCC shows 83% F1 score. For BINDIF it shows 81%, and for diaphora it shows 62%. So thank you for your attention. If you have any questions.
Okay, and thank you for the presentation. Any questions?
I have a small question. Can you explain why do we have these differences?
Mm-hmm.
So what is the reason? This is in the algorithmic based, or
yes,
can you explain these differences?
Yes, for instance, binary code comparison tool uses, so this is the tool that we developed earlier. It uses both hashes, several hashes, and it also uses algorithm to determine it uses program dependence graphs, and it uses algorithm to determine a maximum common subgraph of two graphs. And these hashes plus this algorithm gives us better result. But I should also mention that compared with BINDIF, it works almost 1.8 times slower than BINDIF. Diaphora uses a lot of hashes, but so their quality is less. They don't use, they use very simple hashes, which are not appropriate for when we compile when we compare far programs. When programs are very close to each other, diaphora works well, but when they are a little bit far, their hashes sucks, and that's why we have such. Mm-hmm. Also, there are other tools which are closed. They use dynamic analysis, but so they are closed and we don't have access to them, but they work less, very slow compared with these tools. So very slow.
Mm-hmm. Okay. Other questions? It seems I have a question as well. Frankly speaking, I was thinking that the key for your presentation will be in the test generation system. This should be something new because other parts were already presented in different, like I had a chance to review even some of them. So, especially you have a co-author in theory of information, right? Mariam Hayrapetyan is one of your co-authors. So I was thinking that you are trying to, you most probably will do something in this generation system, but unfortunately I didn't hear something relating to this specific part. Could you please explain in more detail? So, what is the essence of this work? Where is the novelty? I missed something relating to novelty. This is one question, and the second question: you were considering these three tools because they are free of charge, right? Or open source tools, or the rest of tools are just not available. You cannot buy a license. You cannot buy. When you were saying about this list of tools, you said that we are considering these three because others are not even available as tools. I mean, you mean they are not available as tools in general, right? So you cannot buy a license for a tool to use it.
So BCC, we developed our team lately, being developed by Dynamics, which bought Google, which is now free available tool. It's not open source, but the tool is free available. Therefore, is open source tool. But others in other tools. For other tools, we have articles, we have comparison in algorithmic level, but we don't have comparison in tools level. And also, to be honest, Downgrim tool is also available, but it's a very old tool, and it's not working with modern. It's not working with modern programs like disassembler and etc. So it's more than 15 years old tool, so they don't use either Downgrim tool. For the first question, so what we have, why we have done this work, there is no benchmark for evaluating similarities between similarities in level of binary code. There are some benchmarks for Java source code, but there is no available anything to evaluate binary code comparison tools. So at first we thought to create benchmark, but then we suggested to create a system which can everyone develop and use, and it's very basic. So main idea is to choose to select this a project to compare their two versions. If we have source code, we can determine which functions can be matched. So we determine it using the debug information when we compile. Also, we use this system. You can see we use compiler 1 and compiler 2. We evaluate also using different compilers and different optimization levels, because when you use different compiler, the code can be changed. Also, when we have different optimization levels, for instance, O0 and O2, code is changed significantly, and it leads to binary code comparison tools not very good results, as we see in our results section. So our approach allows us, this three-stage approach allows us to show that binary code comparison tools can be compared in such way, and we can have actual result.
Okay. And where is the use of probabilities or models of theory of information? Is there something I missed?
Mainly these tools are used to find bugs. I think we will have chance that we will present our work for bug search using this technology. It's used to find malicious programs. It's used to find to determine patches in software. It used to find old libraries in software. For instance, if you have a software and you use statically linked library and you have forgotten to update its version, using this technology you can find old versions of programs, such libraries. Also, these tools can be used to find copyright infringements.
Yeah, I understand that. I'm asking specifically in your presentation, is there something relating to these probabilities and using of theory of information? I was not able to catch this as well.
In this presentation, we don't have aim to
okay, clear.
We have aimed to only evaluate tools. So
yeah, understand. Okay, thank you. Just wanted you have already answered the question. Okay, I believe we have finished our session. Dr. Astsatryan, we are in time, right? And so
yes,
we all deserve a bonus, I believe, hopefully, because okay. Thank you, participants, for your and presenters for the participation and interesting presentations. We are finishing our session. Now you are free till the next session. Thank you all, and hopefully we'll meet at the next CSIT conference. Bye, everybody. Thank you.
Christina, here was Elisa. Victor. Okay. Now is 2 o'clock. So by schedule, we have to start. But I am not sure whether all our participants are here. Let's just be sure. I see Christina is here. Elisa too. I told already with her. Now Malashonok, Gennady Malashonok. He's here. He's registered. And I am wonder about our Georgian colleagues. Is there some representative from Georgia? Microphone. From Georgia, nobody. I see. Okay, let's just we have the critical minimum to start our session. Okay, so let's start and hope that our Georgian friends will appear soon. So first of all, let me welcome all participants in this not standard situation. We were able to organize and move and push the science forward, especially artificial intelligence. And I am glad that our session is maybe unique, where all participants, we have 6 presenters and 4 or 5 countries that will participate. So that's a big success. I am glad. Sure, you know, and read the program and abstracts and the papers. So just I will overview and say that first we will listen our Christina Sargsyan from French University of Armenia. She will announce a presentation by herself. Then by the schedule, we are going to listen of colleagues from Samara in collaboration with our institute. Then if our Georgian colleagues appear, they will make the presentation. And next will be presentation by Elisa Shahbazian, who generously visited us from Canada. And I am very glad to welcome her because we have a long time collaboration with her. And I hope many of participants, especially Christina, will find points to collaborate because her works are very related to our interests. I told already about you. And the last 2 presentations will be our ones. My colleague Grigoryan will present and me. Okay, let's start the presentations and please use about 12, maximum 15 minutes that we have had a time to ask questions and discuss. And because we had already proceedings and all reports, all presentations are there, so I think concentrate on the essence, on the main, say the core of your questions. Otherwise, it is very difficult in 15 minutes to retell the paper itself. Okay, so please, Christina, we are looking for your presentation. Welcome. Microphone.
Okay. Now is better. Thank you, first of all, for the opportunity to be part of this significant conference organized by Institute of Informatics, which collect under same place representatives from many different research labs. And currently, I will present the topic which is directly connected with the upcoming outcomes we expect to receive soon. Research is under ongoing phase. Current situation with AI today in Armenia and worldwide is clear for everybody. It's significant that advances in statistical machine learning and symbolic machine learning and spectacular results with deep neural networks like different games based on the different rule-based games we are progressed too much, and not only. And moreover, which is very close to the point that we are currently doing within the collaboration with our colleagues from France, is data-driven AI embedded in decision-making processing. And why data-driven AI is important currently? Because as we know, everybody currently, there is many biases in our data, and we discovered that when the internet came up, not the lack of the information, but the quality of the information, and data-driven decisions are more qualified for today. And that's why data-driven AI is a priority for us, and machine learning algorithm connected with the implementation of the data-driven AI is a part of is the core part of our research project. And currently, when we say explainability in data-driven AI, it's connected with the defining predictive models, and predictive models with the explanation of the steps, what will be expected for the as the next stages for the decision making. For example, we can say that currently we use models based on the fuzzy logic and model logic, and moreover, main patterns are connected with the current patterns connected with learning outcome management within the university learning outcomes management. So it's a part which is connected with the knowledge testing and evaluation for the students, but it's a part for the universal model for the future steps, as we hope that it will be done. So the model that we are developing currently will be universal model and not subject connected model as well. Current models partly are more explainable than the others, and we know that decision trees or probabilistic graphical models or the same random forest is usually implemented in different solutions, and worldwide they are recognized, but our task work with the high level complexity and combination of more than 10 or 20 parameters which are work together with the help of deep neural networks. And you ask for sure how it's connected with the trustful solutions and the topic of the current research, trustworthy of artificial intelligence for trusted decision making. To trust, we need to build trust. We need to explain trust our decisions. And when we build or explain, we can improve, and by improving, for the process of the improving, we need to make new discoveries. And for us, it's important that trustworthy for AI, that which in the core of the models that implemented by our team, it's just started part of the work. It's again not end of the work, it's just the start of the way. It's bring to the more transparency of the decisions, which will be helpful for the future trustworthy to the decisions proposed by AI. It's again, as far as you know, there is a law-based regulation in France that no machine can take a decision, only humans able to take a decision. And in this case, it's important for us to provide trustworthy for the proposed decision-driven solutions for, based on the AI algorithms. And when we say explanation, it's important to keep in our mind that explanation will be done with whom? By data scientists, by expert, and who can call expert or user or any regulator. It's connected part with the law in AI. In fact, currently we work very deep with the other department within our university, where a couple of months ago was presented research, AI-driven solutions and their regulations for Armenia as well, in the comparison with European law and law, especially law in France. And the main factors that we take into account when we prepare our predictions based on the data and information, in fact, data, mostly the information, we transfer data to the knowledge, and the trustworthy of the knowledge, we count it on the base of the fuzzy variables. And how realistic the presented solution for presented combination of data-driven solution within the current situation, driven via model logic models of the algorithms. So it's a different worlds that present in different worlds. Different algorithms can present the same knowledge as a different. So the part of the knowledge for the system, for example, within one subject can be recognized as a less important value within the other world, within other subject knowledge, when they connect it together, because for different subjects, the core knowledge as a recognized knowledge for the future decision making can be different. And the fuzziness help to be more trustful, and the model logic help to be more correspond to the diversity which is present in our world, to be closer to the real world solutions. And of course, when we work with the nature of the data, we take different type of the data. The most hardest one, of course, image, audio, and video data, to extract the language and emotions from this part of the data. But it can be trained also on the hand-driven features at the beginning. We start from the first one, and we will move to the last one, to the natural language processing as a progress. And as a last point will be hopefully progress with the image, audio, and the video recognition and management for the data presented in the graphical and sound form as well. When we take a different quality, we count different quality of the data, we took into account 6 dimensions. It's clear in general, just we decided to use these 6 because they are obvious. It's accuracy, complexity, consistency, and timeless, uniqueness, and validity and conformity. The most hardest part for us to recognize the validity and conformity of the data, because especially when you work with the different source of the fundamental data, it can be different. For example, when we try to work with the lessons provided by the Indian professors for the same subject and the professors from Canada and professors from France, we see the difference of the proposed materials within the same subject. And in this part, it's really important to recognize who is the expert, who is truthful source of the valid and conformably data for the future features explained for the natural language processing and for the machine learning itself.
Sorry, 2 minutes. 2 minutes.
It's like last, in fact, slide. And the main expected outcomes connected with AI implementation at work. Work is start a couple of months ago, not long part of the research, but team members has a experience in research. That's why it's helpful to combine experience from the backgrounds. It's a physical AI from one side to be closer to the human-centric paradigm, but at the same time, human-centric AI need to be supported by the trust professionals, and how build the trustworthy for the hybrid decision-making systems. It's our main goal to build this hybrid system when the final acceptation came from the human, as well as acceptation of the trustful source knowledge and source data. Because at the beginning we received data, not knowledge. But if it became knowledge and this knowledge is trustful, we stop this conversation in this point and bring to the hybrid decision-making explainable AI-driven decisions. Hopefully, on the base of the system that will be developed, after 2 years, we will be able to show real results, how it will work on the real system. Thank you, and probably I will be glad to reply to response to the questions which are interesting.
Thank you very much, Christina. So very interesting presentation and work. And questions, please. I have a question. You see, really to evaluate artificial AI and other programming systems and any system, it is multidimensional question and multi-parametric question. And we know that in any estimation, evaluation problem, that's big, there are difficulties. So really, say, even in education, yes, when students say take exams or give the exams, we are in questions whether he really. So I would ask, do you plan any experiments to just work with these parameters criteria, because they are variety of criteria and how they combine and which one will, or how to combine them to make it proper. And do you think about experimental work?
In fact, the experimental work is it's multi-dimensional, and that's why the validity and conformity of the source data is the key point for us. because we take into account the knowledge that we receive from the data connected with the subject. And we took into account, in fact, currently 3 main subjects. It's algorithms, discrete mathematics, and programming. And we keep together the knowledge and data, in fact, knowledge discovered from the data, how they cross between and how they are separate between. And the most difficult point for us, not to take into account different phases, the most difficult to have a trustful source. Because in fact, you know for sure, and all the colleagues can tell currently that we have for the algorithm, at least trustful resources as a books, more than 10 or more than 20. But for the lessons, we can be more harder for the selection, because if we take into account lessons provided from the professors which are available in the internet from MIT, Harvard, and Sorbonne, we see the differences. And the differences are not always core, but we need to discover with the help of AI the core part, and the core part which is the similar for all the professors to present the same lesson will be recognized as a trustful, validity, and conform resource for the future, presented for the future part of the decision making.
Thank you. Thank
Why
you,
decision making? Because decision making, how the students will learn the subject. They need to implement the knowledge, and implementation on the base of the received knowledge. It's a part of the decision making. How new problems will be presented by the help of the AI to the students, and if their solutions will be correspond to the correct solution. That will be checked.
Thank you, Christina. Really, artificial estimation of impact of artificial intelligence or other intelligence system in our systems, and what we doing in real life with natural artificial intelligence, they very coincide. I would like to just mention that usually like in natural artificial intelligence, we estimate eventually our work, our education by on-the-job performance. And I have to just mention that in programming systems, we use this approach in tournaments and so, but we are restricted in time. So if you are interested, I will be happy to share with you our approaches. Thank you very much. Let's applaud Christina for her good presentation. And please, let's start the next one, because we are already...
Sorry, Professor Poghosyan, just I would like to say sorry, I need to leave because I have a lesson, but I will be back soon.
Okay, Christina, now we are, maybe you will be with us in online
sure.
option.
Sure.
Okay, good luck, be with us. Okay, next presentation will be about coordinated optimization of neural networks. Will be presented by our colleagues from Samara in collaboration with our institute colleagues Davit Astsatryan and Mariam Haryapetyan. Please start. Introduce yourself and please start. Okay, microphone, push the button.
Okay, can you hear me now?
Yeah, it's okay.
Okay, just one moment.
Yeah.
Okay, 1, 2, 3.
Yeah, please. Please make 12 minutes because we are over our time. Yeah.
Okay. Good afternoon. I'm Rail Gabasov. I'm a student of Samara University. And today I want to present you our paper, which is called A Method of Coordinated Optimization of Neural Network Parameters for a Given Set of Images. Firstly, I need to mention that nowadays modern neural network architectures are usually trained on large clusters that require a large amount of computational resources. So therefore, urgent is the task of the optimization of neural networks, which can include both increasing productivity and reducing the size of computational power used. In our paper, we present a method of such an optimization of neural network, which is applicable in conditions of information redundancy in input data. Generally speaking, the existing methods of neural network optimization can be divided into 3 groups. The first one is optimization of architecture of neural network and its hyperparameters, such as batch size, learning rate, etc. To the second group can be contributed model compression. And by model compression, we usually mean either quantization, that is decrease in computational accuracy of the weights after training, or pruning, getting rid of some weights after training such that sparse weight matrices are obtained. As of today, the most modern way to optimize the neural network is knowledge distillation. In this approach, we have 2 networks, a teacher network. You can see my mouse, okay. A teacher network highlighted in blue and a student network highlighted in green. The purpose of this method is to teach the student model to mimic the behavior of the teacher model. And I need to mention that the student model is usually smaller. That's the purpose of this approach. So in this approach, we have a loss function, which consists of 2 functions, actually. 2 components. The first one is distillation loss. This is a cross entropy between outputs between distributions given by the teacher and the student model. And I need to mention that in this distribution, the softmax function is parameterized with additional parameter T, so-called temperature parameter. And the second component is the student loss, that is, let's say, a usual loss, a usual cross entropy between hard predictions, so between student model predictions and ground truth labels. And these components are combined linearly as shown by this formula. In our paper, the method proposed is based on the first and the second and the third approach. I need to mention that in our paper, we're considering convolutional neural networks, since this type of neural networks are usually the best tool of neural networks to work with images and computer vision topics. So the proposed method consists of 3 stages. At the first stage, we're proposing to establish the fact of information redundancy in the input data. We're doing it by tiling the original images. Each image is divided into squares 2 by 2 and tiled with one of 3 patterns, which are these 3 squares. The first one tiles 1/4 of the image, the second one 1/2, and the third one 3/4. The green color on the scheme represents either average color of the image or a black or a white color. So in general, we have 9 variants of tiling operations, and their abbreviations are given in this table. DN stays for natural operation, which does nothing with the image. So if the result of neural network training using one of these tiling operations is not worse than the result with using DN, neutral operation, then the fact of the presence of the redundancy in the data is established. And we can go to the second stage. At the second stage, we're proposing to estimate the data redundancy, the information redundancy, by filtering the input layer. We're proposing to use these given binary masks. We're proposing to apply them to the convolutional kernel of the input layer. I need to mention that on this stage, a convolutional kernel is has the stride equal to 2. So when you go with such a kernel with a filter applied through an entire image, you get the same picture, you get the same tiling, let's say, such in the first stage. So there is an equivalence correspondence between kernel masks and tiling operations, and you can get an idea of correspondence by looking at the dotted outline. So if the result of neural network training using one of these masks is again not worse with than the result of using neutral mask consisting of all ones, then the proportion of the redundant information equals either 1/4 if the mask is equal to tiling operation MH0, which tiles the 1/4 of the image. That's the first row. 1/2 if the masks are equal to CHB0, and 3/4 if it is equal to DRI0. So at the third stage, we're proposing to do the neural network optimization itself. So we're proposing to use knowledge distillation approach to train a neural network model with number of trainable parameters reduced by 1/4, 1/2, or 3/4, depending on the amount of redundancy established in comparison with the original model. And let's say it again that by the term neural network optimization, we're understanding increasing the performance of neural network and reducing the amount of resources consumed by it. So to verify this method, we selected, choose the model VGGNet16. So we chose it because it is pretty easy to implement. It has a simple construction pattern. And what's more important, it's easy to perform architectural changes on it. We're considering the problem of classification. So we're using Caltech 256 dataset. It consists of total over 30,000 images divided into 256 classes. We used images from 10 classes to create the data samples. We performed a data augmentation. So as a result, we got 3 pairs of train plus test samples, where every training sample had over than 9,000 images, and every test sample had 300. The examples of the images from the dataset are given here in the figure. This slide shows the results of the first stage of the method. The training parameters which we used are listed below at the left. So if we were to analyze the graphs and the red and green lines in particular, so we can see that the tiling method MH0, which is red, show the best result on the sample number 2 and number 3, and on the sample number 1, it showed a comparable result, comparable to the method DN, so the neutral, the baseline method. And this result is also confirmed by error rate calculated after training. the values of error rate are given in the table. It turned out to be that the tiling method MH0 showed the best result, and therefore we're concluding that the information redundancy in the setup is present, and we can go to the second stage. This slide, sorry, shows the results of the second stage of the method. We can note that in general, over all the three samples simultaneously, the use of mask 101, 111, 101, which is given here below, shows the best result. This mask is applying this mask is equivalent to tiling operation MH0, which tiles 1/4 of each image with black color. So in other words, we're getting rid of 1/4 of the information, which leads us to the idea that the redundancy in the data equals 1/4. And at the third stage of the method, it is proposed to optimize a neural network architecture in such a way that it has 1/4 less trainable parameters. And it was achieved by deleting 2 layers as shown in the picture. The decrease in trainable parameters count was 29%, which is close to 25%, 1/4. Consequently, the amount of resources consumed decreased by 29% also. So, and if we were to analyze error rates, we can see that the result is not only not gotten worse, it actually got better. And about the average inference time calculated for single image, we can see that the gain in inference time is equals an average of 10%. That's basically it. The experimental results which we conducted show that the amount of information redundancy in the data set used can be estimated as 1/4, and that the network model, which is lightened so-called by 29% of the weights relative to the original model, and trained using the knowledge distillation approach, processes each image 10% faster. And the error rates values of the optimized network turn out to be not only comparable, but also less than the error rate values of the original network on the data set used. So that's it for me. I'm open for your questions. Thank you.
Thank you. Thank you very much. Thank you very much. Question, please. Actually, you used a few heuristics in the process. So your final estimation, statistical, this estimation that improvement of the work and shortening the hardware and effectiveness, of course, they are positive and argumentation for that. My question is, do you consider arbitrary input images or classification for arbitrary input data or for some specific classes?
Sorry, could you repeat your question, please? I couldn't hear it very well.
Depending what kind of input data you have. Yes, we can talk about they are different. Sure, if they are related to complicated, for example, if you have to distinguish one technical system from another, which are very sophisticated and detailed, of course, redundancy here might be very low level. But if you consider some, say, space images or related to some terrestrial, so results will be radically different. So do you distinguish these two classes of images, or in this work only consider in general? You took one set of data, standard set, and experimented with them.
So thank you for the question. I have an idea how to answer the question. So basically, this method, the main idea of this method is applicable in conditions of redundancy in the data. So the first and the second stage are basically to help us to establish the redundancy.
But the redundancy is in how you estimate, again, is some heuristics, okay? So in general, if you apply, for example, to distinguish one, say, computer, internet, it's him and so from another computer, okay, or you consider some terrestrial question related to space and so, sure, this method will have different effectiveness, okay? So I think it will be useful to make to think about, or in my opinion, it will be good to distinguish the classes of input data to apply this method.
Yes, thank you. In the current configuration of the setup, if the result of neural network training got worse using these either tiling operations or binary masks, we can say that the method is not applicable. So if there are no redundancy in the data, such as, for example, as you said, terrestrial images, when so in the setup of terrestrial images, we usually have not much information, and we just cannot say that this information is redundant. We're getting rid of it. So the current method will just be not applicable to it, and it's okay.
Okay. Okay, thank you very much. If there's no other questions, let's pass. Thank you. So let's pass to the next presentation. I wonder whether our Georgian colleagues are with us. Merab, new algorithm for improvement of prediction models using data parallelism. Is someone from Georgia here? Yeah. Microphone, please. Microphone switch, push the button. Okay, you will present. Hello, push the button, push the button. No, 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 I don't hear you. Microphone, please. No, no microphone.
The n-dimensional space, including the algorithm for computation of error in this space, and the improved algorithm for using parallel data in the dynamic prediction tasks.
Sorry. We have three options.
Despite the great efforts performed for improvement of prediction models, there are still not discovered those universal models by means of which, using the existing models, it will be possible to build models providing much better results during prediction. Hybrid models are mainly proposed, which do models providing much better.
I'm very sorry for interrupting. You are online or you are in the home?
Hello. Hello.
Okay.
Hello, I am Natella Archfadze. I present our works with video in English and the comments in Russian.
Excellent, excellent. Because initially your microphone was switched out, so we didn't hear. So please repeat and start, please. Okay, we are ready to listen to you.
Thanks. Давайте пропустим.
You can make it in the Russian too, any language, even in Armenian.
The paper reviews the issues of improvement of existing prediction.
Можно на русском?
Можно, пожалуйста.
Можете? Ой, тогда.
Понимаем, да, по-русски. Пожалуйста.
Это закройте.
Прогнозирование уже давно является одним из ведущих частей науки.
Это закройте.
Если человек знает, что ожидается, и к этому готовится, естественно, все это будет с меньшими потерями, но все равно это, естественно, все равно сбудется. Ну, предсказания имеются уже давным-давно. Были, конечно, ненаучные, ясновидящие или многие шарлатаны предсказывали разные вещи, но как научная дисциплина она сформировалась недавно. И она обычно опирается на так называемых предшественников, особенно научных. Мы создали теорию, которая, если имеется несколько моделей прогнозирования, как можно из этих моделей создать более лучшую модель. То есть создать такой модель, который на одну голову выше предсказывает события. Мы для примера здесь будем рассматривать прогнозирование для землетрясений. Мы знаем, что в этом институте, имея суперкомпьютер, в дальнейшем собираются тоже работать над прогнозированием землетрясений. Тут есть такая вещь, ну это уже не моя, вот один из ведущих прогнозистов России, Алексей Завьялов, заявляет, ну я, конечно, с ним очень хорошо имею связи, он заявляет, что все имеющие модели, вероятность предсказания не больше 3%. Не больше 3%. И они все говорят, что мои прогнозы самые лучшие, если, допустим, чуть-чуть на какой-нибудь 0,1 или 0,01% лучше работает их модель. Но все они говорят и радуются, что все, которые события случились, они предсказали. Но никто из них не говорит, сколько раз они ошиблись. И вот этот процент, как раз 3%, и говорит о том, как они хорошо предсказывали. То есть 97 раз из 100 они ошибаются, а максимум 3 раза они предсказывают. И если к этим предсказаниям верить, представляете, допустим, перед землетрясением 97 раз надо готовиться, и миллионы или миллиарды долларов на это терять, что ждет землетрясение, а в действительности случится только 3 раза. Поэтому на эти прогнозы никто не идет. Здесь бывают разные выходы. В Японии, допустим, они идут к следующему путю. Они взяли 500 разных, самых высокопроцентных предсказаний, прогнозы. И вот на этих 500, чем больше из них будут предсказывать, чем больше они думают, что прогнозы более правдоподобные. Ну, да, хорошо, конечно, иметь 500 данных, 500 разных моделей, но это очень большие деньги. Ни одна другая страна не может такое себе позволить. Особенно маленькие страны, как Грузия, Армения и другие. Есть еще так называемое создание гибридных моделей, когда берутся разные модели, из них строятся так называемые гибридные, которые учитывают как одни предшественники, так и другие и так далее. Мы вот создали, можно сказать, теорию параллельных данных, которая применяется для прогнозирования разных событий, в том числе как статистических, так и динамических. Ну, статистические могут быть такие, как, допустим, тактогенические и все природные события, которые могут вашим жертвам принести, так и могут быть разные прогнозирования медицинских событий. Но сами, можно сказать, имея очень большие данных, очень хорошо работают и над динамическими событиями, такие как прогнозирование курса валюты, прогнозирование политических событий и так далее, и так далее. То есть мы не предлагаем новую модель, а мы предлагаем из существующих моделей, как построить прогноз, который будет намного раз лучше. А в чем она выражается? Она, ну, для примера я буду говорить о землетрясении. Ну, допустим, есть модель, которая предсказывает с 3% и 97 раз не совпадает, а 3 раза точно предсказал. Есть другой модель, который тоже, допустим, 2% или так далее, 2 раза точно предсказал, 98 раз не совпало. Да, если мы возьмем, допустим, мы сравним эти два прогноза и посчитаем, когда они одновременно дали прогноз, что это событие произойдет. И посчитаем. Оказывается, что их пересечение предсказаний уже не 98, как один или 97, а тогда, когда они друг с другом совпадают, где-то 10-12 раз. А если 10-12 раз они одновременно дали прогноз, из них только 2 раза или 3 раза это событие случилось, уже на много раз прибавляется процент. А в чем сейчас проблема? Проблема в том, чтобы иметь побольше моделей, из этих моделей, как поймать те пары, которые вместе работая дают прогнозы на одну голову лучше. Допустим, есть один прогноз, который 90 имеет 3%, другой, допустим, 2%, но они вообще не пересекаются. Они одновременный прогноз не давали, кроме тех, когда событие правда произошло. То есть что происходит? Их пересечение 0, а пересечение, когда прогноз даем, вот такие пары, если найдется, это означает, что эти пары вместе дают 100% прогноз. Потому что они пару дают, а отдельно может 2 и 3. Предлагаю эту методу, в Грузии очень много прогнозистов по землетрясению, все они побоялись давать свои данные. Ну, мы всех говорим, что вы не бойтесь, если даже у вас 1%, если 0,5%, то, может быть, найдем такую пару, вместе с которой вы уже дойдете вместе до 70, до 80%. Сейчас второй вопрос. В чем заключается загвоздка данного метода? Для этого нужно, во-первых, иметь очень много данных, чтобы можно было из этих сравнивать, находить пары. А если мы найдем не пары, а тройки или четверки, они еще лучше дают прогнозы, и их проценты уже выше и выше поднимаются. Ну, допустим, если мы найдем хорошие 2-3 пары, их поиск таких пар и потом их применение, уже на это будет тратиться уже реальные деньги, которые и Грузия, и Армения может полностью позволить себе. А если уже проценты дойдут почти 70-80%, я думаю, что это уже реальные данные, которые можно верить и прогнозировать. Ну, прогнозировать не только землетрясения, но и любые модели, которые прогнозируют события, но имеют обязательно историю, имеют данные. Вопросы тут еще разные. Вот. Очень много вопросов. Как их обрабатывать? Если очень много данных, обычные компьютеры с ними не справляются. Естественно, надо обязательно суперкомпьютеры применять. Не только для нахождения пар, но и в дальнейшем для их реализации. Тут еще вопрос в том, что вот эти процентные нахождения пар, не обязательно эти пары все время одинаково работают. После каждого события, когда случается какое-то событие, и они прогнозированы, после этого надо заново пересчитать и проверять другие пары. Тут есть еще много вопросов. Ну, мы с этими вопросами работаем. Вопрос, что такое совпадение? Как совпали вот прогнозы? Совпадения могут быть разные. Допустим, со временем, допустим, 24 часа, место района, где прогнозируется, что произойдет событие. Это все дело эксперта. Это может быть, допустим, 50 километров радиуса. Для землетрясения существует третье данные. Это по Рихтеру, по шкалу Рихтера, какой силы землетрясения. Ну, допустим, если разница 0,5, уже по шкалу Рихтера 0,5 силы, это уже близко и так далее. То есть для каждой области эксперты определяют, что такое совпадение. Вот для землетрясения определили, допустим, для оползни отдельно там другие данные, другие вещи. Но тут мы вот еще вывели...
Я очень извиняюсь. Ваше время
да, я кончаю.
Да, пожалуйста.
Да. Мы вывели такую вещь, что, допустим, если возьмем n-мерное пространство, допустим, для землетрясения это трехмерное пространство, которое место, время и сила землетрясения. Тогда можно будет вот эти данные, каждая единица этих данных, и между ними вот в трехмерном пространстве, у кого самое меньшее совпадение, это считается событием. Да, и в конце я привожу литературу по этой тематике, которая нами были опубликованы. Но мы надеемся, что практически вместе с местными товарищами, к сожалению, в Грузии, в нашем институте уже давно, 8 лет говорят, что будет суперкомпьютер, но нету. Надеемся использовать, если будет разрешение, конечно, и ваши данные, и ваши компьютеры для осуществления наших методов. Спасибо за внимание.
Спасибо, Наталья. Вопросы, пожалуйста. Ну, пока думаю, я вопрос задам. Конечно, использование данных из разных источников, ваш параллель, в сути, я так понял, что вы концентрируетесь на, конечно, многоаспектно, рассматривать проблему многоаспектно. Но вопрос в том, что это действительно очень сложно учитывать все многообразие, которое может повлиять на... Были ли какие-либо эксперименты, подтверждающие вот вашу эту интересную идею?
Мы, во-первых, теоретически доказываем, что любая лучшая пара работает лучше, чем самый лучший прогноз. Это очень легко теоретически доказать. У нас соответствующие статьи есть, теоретически доказываем, там несколько теорем.
Это у вас как теорема, как-то, потому что это
Да,
тоже
мы
область
теоретически
формальная.
доказываем, а экспериментально, не только теоретически, экспериментально мы это проверили, допустим, на курсу национальной валюты. Там легче, потому что там все время дается прогноз из имеющих прогнозов, почти как ежедневно дается прогноз, какой будет, допустим, курс лари к доллару. Есть разные методы, есть разные модели. Из этих моделей мы показываем, какая пара лучше всех работает.
Ну и финансисты как принимают? Это же очень такая обещающая направление.
Тут можно сказать,
заработать хорошо на это.
Да, многие не хотят такое применять, потому что каждый считает, что вот я создал свою модель, и вы портите применение моей модели, ищите ему другую пару. Это не только тут, и в землетрясении прогнозировать, и везде. Каждый хочет свои данные беречь, не хочет не давать и не продавать, и ничего. И очень дорого нам обходится, чтобы их уговаривать. В том же дело и насчет здесь финансов. Но, естественно, есть такие организации, которые это хотят применить, или такие бизнес-компании, с которыми связываемся, чтобы они как раз находят и выгоду от этого применения.
Спасибо большое. Если нет других вопросов, поблагодарим.
Можно один короткий вопрос?
Короткий вопрос, пожалуйста.
Да. Я думаю, будет много заинтересованных организаций в прогнозировании курса валют. Это можно, в общем-то, благодаря этому можно очень быстро разбогатеть. Но я боюсь, что запретят вам продолжить эти исследования. Но вопрос такой. Может быть, это вам принесет пользу для уточнения ваших моделей с большей точностью. Так как вы уже в Грузии проводите на этом объекте, на валюте, на вашей валюте такие исследования, может, стоит параллельно провести два исследования вот вашими методами и спрашивать мнение 10, 5 или хотя бы 2-3 экспертов по обмену курса. Хотя вы считаете их, в общем-то, ненаучными. Ну вот если будет их мнение, 3-5 специалистов, тогда, может быть, сравните эти две данные.
Я уже говорил, еще раз говорю, чем больше экспертов своими методами к нам дадут свои эксперты, как они вычисляют, то есть дадут нам, как работает их модель прогнозирования. И не только в валюте, в любой сфере. Если есть модели, уже есть модели, из этих моделей мы извлекаем пары, тройки или четверки, которые 10, иногда и 20 раз лучше данные дают. Но они должны согласиться, что мы их данные возьмем еще все остальные, которые имеются, и найдем пару. Больше скажу, мы в ближайшем будущем собираемся создать сайт прогнозов. В чем она заключается? Все данные, которые у нас есть, любой, который имеет свой прогноз, он к нам обращается, дает свой метод прогноза и данные, мы находим им пару в любой области.
Можно я уточню вопрос?
Да.
Я вряд ли кто-нибудь свой метод даст, но я имел в виду футурологов, тех, кто деньги считает.
Время другого прагматика. Так что давайте оставим.
Футурологи, которые деньги считают, у нас один миллионер очень хорошо считает.
Спасибо еще раз. Я вижу, интерес есть. И многие хотят обогатиться, но давайте к следующему докладчику.
Тут главное, еще раз повторяю, не обогащение, а главное, чтобы спасти людей, экономику и так далее. Если землетрясение будем давать...
Это как шутка.
Да.
Это скорее как шутка. Так, спасибо еще раз. Давайте
спасибо
перейдем
вам,
к следующему.
что предоставили.
Да. С удовольствием предоставляю наш, Элиза будет, наверное, на английском или как? So we do that with, если, в общем, Элиза может выбрать любой язык. Нет проблем. Я очень извиняюсь. У нас Геннадий Малашонок здесь, да? Алло. Алло.
Алло, да, я есть. Я пока включал
Да,
микрофон.
Я так смотрю, уже ваша... Вы в команде, да, были с этого? Уже презентация ваша была?
Нет, я буду завтра докладывать.
Вы завтра. Я так смотрю программу, не ошибся ли я? Ну, нет, как будто все в порядке, идем по программе. Так что, Элиза, пожалуйста, можете на любом языке, наверное, на английском вам удобно будет. Пожалуйста.
Presentation view.
Տեսնում մենք տեսնում ենք։
Չէ, ուղղակի presentation view-ն չի։ Այսպես պետք է մի հատ բան անենք։ Page view-ն պետք է գտնենք, չենք հասկանում ուր է։ Files, view. Միրը սա։ Չէ, բան է, մի քիչ շատ մեծ է, չենք հասկանում ոնց փոքրացնենք։ Ավայ ճիշտ է, ներողություն, ճիշտ է ասում։ Եղավ։ Շնորհակալություն։ Hello. I will present a tool developed by our team at UDA Technologies in Canada. It's about 2 decision support tools that analyze the situation and provide courses of action estimation from open source information. So the outline is, I'll introduce, I'll explain the whole concept. OSCAR and Hypothesis tool are the 2 applications that we developed using different approaches, rule-based AI. Our group does not specifically focus on a specific solution, but we're very good at finding how to bring all the pieces together to make something happen, to apply it in an application. And then how this tool collaborate for various applications. We've implemented the most recent application that really demonstrated the strength of this tool collaborating to produce a solution. So the introduction. We all, when we think, we go through the decision cycle. And this decision cycle is we collect data, we make observations, we come up with a situation assessment, and then we decide, and then what? So what am I supposed to do? And we've been in the data fusion technology since 80s, where the technology is an approach rather than technology, where you use any kind of discipline to bring knowledge from any source to build situation understanding, and then to come up with, okay, now that I understand the situation, what am I supposed to do next to achieve my goals? The challenge here is, I mean, the data fusion technology is really, really good at coming up with this, going through the decision cycle based on real, easy to quantify observations, but it's a little bit harder to do it with open source, social media, and especially when there's too much data. And in these applications, we came up with this approach of estimating observations and building situations from fusion of soft data in OSCAR. And I'll tell more what is OSCAR, and then coming up with how do we go about, so what does it mean to me and what am I supposed to do next? OSCAR means open source information collection, analysis, and reasoning. It's a little bit more mature than the situation tool, the other tool. We've applied this to all kinds of different applications, including finance, but at this point, it has become much more mature for this kind of applications where you collect data for any purpose based on that domain ontology, and come up with analysis of what's the situation for that domain. It uses basically natural language processing and applies some interesting fusion concepts to not double count information. I'll talk more about that too. It starts with ontology, which is entities of interest and their relationships, and then extracts data, knowledge out of raw data using detection rules and domain taxonomies. And at the end, well, we can make OSCAR read huge volumes of data of any kind and just come up with the situation understanding. Here, we were looking at people, governments. This one was a way of putting a social network, meaning entities and their relationship. But there's other ways of presenting. It depends on the data, on the application. So this is the processing of what OSCAR does. It goes into search space, goes and reads anything it can read. You choose what it has to read based on the domain taxonomy, and you try to make this taxonomy broader than you really need not to lose information. Then you use natural language processing to detect entities and recognize and detect entities of interest, and rule-based processing to kind of score, quantify the detected information in each document. Then at the end, the fourth process is to basically fuse the detected information, because you're going to collect a lot of information about any specific topic. To fuse the information, we cluster documents on the same topic, and we use some algorithm to score the observation based on preventing double counting of that data. So at that point, after you already score your data, you can build your network, whichever way you can present the information, whichever way as your application requires. The hypothesis tool, when you have a hypothesis, when you have a course, you want to understand, so what next? You build hypotheses. If I am going to, if I have this kind of situation, I can do this or that or that. And based on the data coming from Oscar, you can, or any other source, you can come up with this hypothesis makes more sense. That the main meaning of this, the main reason why we came up with this tool is to quantify likelihoods of various hypotheses and then decide, so which hypothesis, which way I should go. It's a reasoning engine. It used preference-based fuzzy argumentation and includes both support and attack relationships. And we also use the person's, the user's estimates feeling for how much they trust, how credible this data is and all that. We built a hypothesis tree constructed all propositions, hypotheses for what kind of outcomes they are. That it's based, these propositions, this whole hypothesis tree is based on application taxonomy. And if that correspond to arguments in the hypothesis tool, then it ingests any type of relevant data to assess and compute likelihoods for the hypothesis. Ouch, no, this went too far. So this is another picture of the processes that happen. Well, it's kind of I already said most of it, except when you get an observation that's not in any hypothesis, you can create, augment your ontology and create more hypotheses, and you can continuously build your outcomes using the hypothesis tool. And this one is just showing how this argumentation, it's just an example how the argumentation framework works. So it's just the definitions on the left side. And then the proof is just some observations that confirm the propositions. You can have inference link, just either support or reject the proposition. And so basically at the end, you end up with score based on both human assessment of the trust and weight and all that, as well as the scores from the detections of the argument, the observations that come in. So basically, in theory, you can use OSCAR for anything. You can use OSCAR to just build knowledge about what's happening in the news, or what's happening in finance or whatever. Or you can use hypothesis to not necessarily with OSCAR, to feed it any kind of other information, feed the hypothesis tree with any kind of other information and assess courses of action. But we have come up with them working together and they both learn from each other as they work together and refine the whole understanding of situation, as well as understanding of courses of action. Well, the decision cycle, observe, orient, decide, act. This is just, I forgot to tell that that's what data fusion works on, mainly does. So the OSCAR does observe, orient, and hypothesis tool has decide, act, estimates, decide, act. and they can continuously collaborate. So the way they collaborate, it's based on the taxonomy to derive detection, because Oscar uses taxonomy to derive the detection. And then when it goes to the situation tool, hypothesis tree is also constructed with a taxonomy. And so whenever an argument is created, the hypothesis appropriate detection rules are necessary in Oscar. When the new argument is created, Oscar search space enhances, and it comes up with more data, and then the hypothesis tree hypotheses enhance, and so they continuously teach each other to do the OODA loop better. Now I will describe applications in reverse order, the most recent one. So this is the most mature. What we did is we applied Oscar and hypothesis tree to analyze huge volumes of information collected for COVID-19. So we came up with a tool, not necessarily for COVID-19, it's for any kind of emergency. We came up with a tool where you can keep watching, observing news articles, people talking, and all kinds of Twitter messages, whatever. You can keep watching, and then you have hypotheses that is maybe health emergency, or maybe it's not a health emergency. And so you keep feeding the hypothesis tree with whatever information you detect. And then at some point, a likelihood of a specific thing happening can be observed. And then you can identify it's a health emergency. Or the other two are older projects, but in all cases, I will explain more how these Oscar and hypothesis tool would support different applications. So that is the system we put together for health monitoring. We imagine that there is a computer that listens to everything, reads every news article, and reads every scientific article, and it feeds data to Oscar, and Oscar makes detections. On one hand, Oscar puts the detections on map of a city and looks at where in the city this disease is happening. In theory, this can make you observe a neighborhood where people are older, or there is more disease happening, for example. And on the other hand, it feeds the hypothesis tool, which calculates some disease likelihood. If nothing happens, hypothesis tool doesn't have any, doesn't increase any of the hypotheses, and at some point, one of the hypotheses likelihood is going to go up. The bottom pipeline has nothing to do with Oscar and hypothesis tools for now. It's just monitoring what happens to the disease once it's already there. We imagine that eventually one could feed those observations to hypothesis tool as well, maybe to monitor is it getting better and all that stuff. But we haven't done it in this project. What we observed using just canned data from COVID, that if we had one of those at WHO, they would declare pandemic in January, the latest, rather than March, based on the data we have. We just downloaded. This one was only using Oscar, and it was to analyze open source data to observe some kind of geopolitical situation happening based on a specific taxonomy. This was for a space situational awareness. We were working with some politicians who wanted to understand, like India was at the time performing some, they destroyed their own satellite and created a lot of debris and all kinds of situation. Would there be possibility to prevent this from happening by watching open source data and by predicting they're going to do it and do some sort of deterrence activity? So, and it turns out that they observed a couple of detections from open source that they could have used if they had a tool like that. So they said at this point, they want to redesign, rethink their deterrence processes. And finally, this was just military intelligence analysis using open source data. Well, if somewhere some military activity is ongoing, can you understand who is whose friend, what's going to happen, where it's going, and all that stuff? And we also, in this project, we also use soft data to put some learning approaches to detect sentiment. Oscar also produces sentiment to fuse the sentiment data and detect some emergency situations, again, from soft sources. Basically, these are conclusions. Am I on time? I speak fast usually. These are conclusions. These both tools are still total prototypes. They're not really applications. And so there's a lot of stuff we have to do, but we did demonstrate in the past 3 projects that there is very good use for tools like this. And well, it will be interesting to continue using it. We are using it in other places, but these 3 were the best, let's say, examples of how these things would be, this kind of watching open source and doing this kind of UDA analysis of data can produce information that normal people just reading news could not predict. Done. Any questions?
Thank you very much, Elisa. And you just my partner moderator ask whether questions. Any questions, please?
I have a question. You can use any language.
Well, I want to understand how you evaluate how much improvement you have with adding the hypothesis to Oscar. So, I mean, do you consider
good question.
any error probabilities? Or
well, we do. I mean, at this point, these are, like I said, prototype. While we evaluated in the case of COVID is comparing ground truth to what we just observed. The ground truth was the news, and everybody says that this is what the disease behavior is. While we came up with some, we observed something that people didn't know. They could have detected and they could have prevented COVID sooner. We don't. For the moment, I heard a lot of trusting AI and read a lot about trusting AI. At the point, these are not precise scientific results. These are be careful, something is going to happen results. And in this context, coming up with exact, precise measurements, we are not there yet.
Okay. Thank you. Maria, microphone, please. Microphone.
Isn't it on?
We haven't tried that. We haven't tried that. See, when we do these kind of projects, actually, it's interesting. That project about COVID is a multi-phase project. We did the first phase for the Canadian government, and they said, let us think, maybe we want another phase, but we haven't yet decided. So if we get the next phase, then we will also worry about these things. But it's kind of on hold at this point. It's on hold. We've done the first phase. We're waiting for their decision.
Okay, thank you. Other questions, please? I have a question. Actually, really, Oscar looks very attractive, and your experience and your just work with them is very valuable for us too. Are you satisfied by its output and how you can estimate usage of Oscar in general?
Your question is, are we satisfied?
Yeah, whether Oscar is really
something like this can improve indefinitely. I mean, right now it can make some conclusions that appear to be useful, and we can improve it indefinitely. And it is being improved indefinitely. So fuzzy argumentation. Fuzzy already says that it will, we don't know how to make it more precise, but it will become better. I mean, it has a potential for improving indefinitely.
Actually, Oscar led us to construct some ontology, yes, based on the text, on the textual data, or on the symbolic data.
You start, see, the best is if you have professionals who are domain experts, you start with an ontology in collaboration with the professional to help you build the broad taxonomy for looking data, and then a more precise taxonomy for detecting knowledge. And so you have to start from ontology, otherwise Oscar is going to get lost, he's not going to know what to look for.
So ontology provides experts. Ontology provides experts. Okay, say if eventually we constructed ontology and Oscar worked, and after the question of prediction, yes, prediction and prognostication. And here to coincide knowledge, any prediction, as we know, is a search of some strategy. Yes, strategy. You have to consider all possible versions or situations, influence of the.
That's hypothesis too.
Yeah, and very difficult question. And did you evaluate prognostication, your tools of prognostication by itself? So how they effective and how they involve knowledge in this process? Because, you know, we are interested. Yeah, please.
It is a young technology. It's being evaluated, but it has proven itself with COVID data. But it's a young technology. And we will continue to evolve it.
I have to pay your attention that actually it very coincide with our interest. And you know, we did one collaborative work in predicting defense question. And in chess, actually, Botvinnik approach, and we continue this. And now CSIT will report about our work in the field, how to bring knowledge in decision making and how to make it, use it for prediction. So if there's no other questions, let us pass to the next presentation. And I pass the floor to you, Eliza, because you are
because both presentations have something to do with you. Yes. Who is the next speaker?
The next presenter I will help you is CSIT Grigorian. I'm sure he is somewhere here. So Setrak, please, and I pass to you, Elisa, continue, because the next presentation will be by myself. Setrak? Setrak? I don't see Setrak. Ah, he's here. Okay. Start, please, Setrak.
Hello, everyone. I am Setrak from Institute of Informatics and Automation Problems. And I will present our approach in automating acquisition and explanation of strategy knowledge. So, generally speaking, human-computer communications can be considered in different types of, with different types, say learning, acquisition, explanation, and learning itself can be different ways, but we concentrate on acquisition and explanation problems on expert systems and cognitive architectures, where actually knowledge acquisition is still mostly performed manually. So the expert or the user gets in front of desk and starts trying to define the knowledge. And this is one of the most problematic parts in this field. And we also have a similar system, expert system, where we also have some solutions and have some difficulties in this knowledge acquisition and explanation part. So in this work, we try to advance in automating human-computer communications in that space. As I mentioned, generally in such systems, expert systems and cognitive architectures, it's mostly performed manually. However, there are still some advances. Lately, some publication was in a conference in space of cognitive architecture, where they provided a good solution for procedural knowledge acquisition, but that was actually related to procedures, not the details inside the knowledge. And we also in our system have it's called RGT. And in RGT knowledge, we have interface for its insertion. We had some learning algorithms, and we had some advances already in neural network integration for classification of different types of classifiers and objects. And for the background of this research, we rely on the systemic classification theory provided by Edward Poghosyan. And the main idea we use here in that scope is that mentals are considered as systems of two classifiers, and their learning is mostly reduced to assembling already learned classifiers and their relations into the systems, where each classifier can be described different ways, for example, with neural networks. So where we try to solve this task, as I mentioned, is the RGT class of problems. It's named RGT because of we consider that the space of solutions there are reproducible game trees. In the right side, you can see the game tree for the chess. And to bring a problem to this space, we have the several actions. If they have to they need to have interacting actors which have identified types of actions to perform, and these actions are performed in specified moments and in specified situations, and benefits for each actors are identified, so we call them goals. And after making some actions, these actors transform the situation. And this class is interesting for us because we considered it as a model for human universe problems, and a lot of urgent problems are reduced to this class. For example, there are network intrusion protection problems, management problems, different types of battling problems. So, for example, naval ship defense problem, and also chess and chess-like combinatorial games are reduced. And since we have it is showed that kernel of these problems is unique, so we can spread the results of a problem to all of the space. We consider only a single problem and try to spread the results for that on all of the class. And for this, we try to develop a unified RGT solvers to include these problems and provide decisions in that scope. So current tasks here are to advance in RGT knowledge acquisition and RGT knowledge explanation in scope of RGT solvers. Currently, we have an interface to define this knowledge, and this is as similar to other solutions. It's like defining the rules, regularities, and we have a model behind named HBD model. It's based on English language dimensions, have, be, and do, and it keeps the knowledge with classifiers with that relations. So we have a network where each knowledge represents a tree from starting the node with its relations. So how we try to improve this acquisition? First, we try to keep strict formatted texts which declare some kind of knowledge, and we try to integrate it into the existing network. For example, if we try to define chess concept knight with such a text, it will try to find its parent, integrate it with it, then find its attributes, integrate them, and if we have defined actions, it also will integrate them. And since we might need to define regularities in them, we also will be able to define this with similar to databases, knowledge-based languages. We can use where keyword and specify that. So we also, since it's strict formatted text, we are trying to improve that to use free-form texts and integrate them. And currently we are trying to integrate this START program, which is cognitive architecture-based program and provides triples for texts for English language. It's like provides a tree of hierarchy of triples for each provided text. And we are also trying to improve it with ML machine learning based solutions. Currently, we are trying to integrate, we are integrating lemization and stemming, but there are, of course, better solutions which we try to use later. And since it's using rules with numbers, we are trying to get rid of numbers and provide you human adequate situations. We are trying to integrate more NM classifiers, which will be able to demonstrate actual presentation of the classifiers themselves. And the explanation comes to representation of each classifier with its relations. Previously, we had descriptions for each classifier in scope of personalized tutoring for chess. But here, since we have an English language-based model, we can provide English text for each classifier. This actually comes to a problem when you're getting to abstract concepts like or virtual ones. So, for example, in this case, field under attack, we are trying to get to its specifications where each specific type of this classifier appear and provide their descriptions. And after, for this, we also provide this text for each classifier. And as a summary, we are developing algorithms. We have developed some solutions for classifiers learning from strictly formatted text and some approaches to overcome these strict format solutions. We use different solutions, for example, neural networks, to allow adequately demonstrate these classifiers explanation and acquisition. And also we are experimenting this for this RGT scope of problems, and especially in RGT solvers, we have some successful results for integration of such classifiers with text. And thank you.
Elisa, continue.
How do you apply this?
Actually, we have a solver where which we apply to provide strategies to provide solutions for this type of problems. And this is the one of our main problems. It's a common problem for such expert systems and cognitive architectures to define the knowledge. So it's applied to improve our insertion, acquisition of the knowledge with such solution. So it's kind of enhancing to communication between experts, which you will use this program, and the solver itself, which will integrate the knowledge transferred by experts.
Very interesting. Any other questions? I guess we will go to, we're already late. So Edik, you want to start?
Yeah, I'm preparing. I'm finding how to share my screen with you. Start video. Okay, start video. You cannot start your video because the host has stopped it. Why?
Overall, it's an interesting theory.
No, actually, I would ask the technical assistance, because you say you cannot start your video because the host has stopped it. Host, why it stopped it?
You need to press share screen button. There's a share screen on Zoom.
I am looking for this.
It's the bottom part.
The share screen. Okay. Okay. Share screen, and I am going to computers. No, inbox. Just a second.
You have to open your file.
Yeah, I'm looking for. I am going to my presentation. Zoom join a meeting. Why it is just. Oh. Alo, te lăsăm.
You should close.
Eu lăsăm. Ce yes, banım, sesayım. Hima o aki inşoş banera, koçun do. Ce, file in bața. Documentele, ca S file na. S file na. Aha. S file na. Who is pastoren? Verim. Naimem sharing ayo. Ima sharing stop emanu. Pertume miçur bana anımı livaki pastoren halapes. Join a meeting,
No, you need to first stop sharing what you are sharing and then start sharing the other one. Stop sharing, open the other file and start sharing again.
Ես ուղղակի գնում եմ Zoom meeting-ին ինքը չի բերում, Zoom control. Meeting control.
Mi had stop sharing ըսխմի.
Չէ, ուղղակի չի դուս տալի, ընդհանրապես չի դուս տալի բանը։
Հիմա դուք ընտրել եք, հիմա ձեր մեյլի բան եք, էկրանն եք դուս տվել։
Փաստորեն ես
Հիմա եթե բացեք բանը, պրեզենտացիան էսեջում կտեսնենք, էլի, եթե էսեջում բացեք։
Ես հիմա Windows, եկեք մի հատ նորից մտնեմ, այդ Zoom-ը։
Okay.
Երևի այդ նորից ճիշտ է, որ նորից մտնեմ այդ Zoom-ը։ Մի հատ նորից մտնեմ, որովհետև ինչ-որ խառնվեց, մինչև այդ լավ չի չէր տալիս, հիմա խառնվեց։
Մինչև մտնենք
Stop share գրածը, հիմա եկավ, լավ։ Share screen։
Ես կնախընտրեմ, որ ես
հիմա ես գնում եմ, չէ, իմ կամպյուտերը բանը, այստեղ Poghosyan և հիմա ոնց է, լավ, ուղղակի բացեմ, բաց է, այո, բաց է, բաց է, լավ, տեղավ, տեղավ, հիմա լավ է, F5, լավ, այդպես եմ անում եմ, F5 ու F5, եկավ, նորմալ է իմը, իհարկե, I am very sorry for my...
It's okay, let's go. You are 13 minutes late.
Okay, but it's just, it showed that I'm out of the session. That was the reason, sorry, but I will try to save your time and I will do my best to do that. Okay, so my presentation is entitled Specifying Adequate Models of Cognizing. And I would say that our problem, a general humankind problem, is being the universe is overall mystery of humans. And we try to resolve this problem. Cognizing is our instrument. And we do that. All the humankind, as we know in history, and now all religion, philosophy, and all ones who thinking over the narrow profession, they all ask this question and try to resolve it. And research in artificial intelligence coincided with physicists and other researchers have some hypotheses and some advances in the field. And what we have and what our attempt to answer what is the topic of my presentation. The main hypothesis that we are actually propagating and following and try to prove as a result of our long time studying is the following. Non-cellular negentropics of the type of energizers can originate in nature, then develop at least up to the highest human cognizers to reproduce themselves in a variety of modes, particularly in the cellular modes. Now, I have to make some explanation because, or recall some of terminology. You know, the term negentropicity was introduced by Schrödinger when he answered or tried to distinguish, classify what is alive. So he found that all realities in general, they are entropic, so they losing energy, and only alive systems are able, or actually one of the systems, very unique systems, with they gain energy from others and preserve their organization and their being. Of course, that was this definition was given in connection with a life system, with life systems. But negentropicity is a characteristics which is an attribute which can these days we can associate with many even technical systems, because if we consider satellite, so satellite actually can gain energy from all over, so they are constructed anyway, they are have this attribute of negentropicity. Energizers we define as a primordial minimal negentropics that include some minimal thing to preserve their negentropicity. Actually, they include or we assume they have to include classifiers of energy, energy gainers, classifiers of favoring and damaging them realities, effectors to implement their controls, as well as controllers governing constituent all these constituents. And human cognizers we have defined before. We understand or we define as negentropics with overnet energizers, with in collaboration with their communities, can learn and organize mental systems, the mental system for preserving their personal and community utilities. Okay, sorry. Let me do the full view. Okay, it's okay. Now I have no problem. Yes, you see me. Elisa. Hello.
Sorry, I forgot to press the, yeah, we see you, it's good.
Ah, it's good, okay.
I mean, you're not in presentation mode, but it's okay, we can see you.
Only me or presentation too?
No, we see only the presentation, not you.
No, that's just not so important in this context. Okay, so recalling what is our hypothesis, it says that no cellular negentropics can originate energizer, cognizers, and so. And we discuss all this question in our recent work, which is summarizing our research findings. And it says that computer-dependent solvers of combinatorial games can be developed to approach to adequate models of human cognizing. And we demonstrate by different applications by our theoretical studying. And one important constituent of this our argumentation is our address to the roots of cognizing, which we understand as a classifiers. Recall that any science starts with classifying. Recall that our developing is starting from classifying. We learn from childhood elementary things, and after development, eventually we come to the full natural language, which say in English includes about 1,000 concepts, 1,000 classifiers. And these classifiers, first of all, take a role of distinguishing realities. But when we're going to the, say, more advanced usage of these classifiers, we come to ones which are actually accustomed for sciences. And in the highest form of science, just in physics, mathematics, chemistry, we understand that classifiers have to be not only distinguisher of realities, but it have to be regularized. What does it mean? That we have to be able not only name some reality, distinguish it, but we have to be able to provide it some samples in regular way. Actually recall the physics or other sciences which is constructed on the ability to reproduce the thing that we say. If some scientists discover some event, some new, it have to be available and reconstructible. It have to be repeatable. And regularization concept actually formalizing these aspects of our modeling. Here on diagram, I represented the target elements which are talking about. And you will see in the yellow on the right side, it is not, it is, or in the bottom, we see those which are not regularized. And actually we have the majority of our realities and our concepts classifiers are not regularized. I have to mention that we, in our, what we find important, we talk in our consideration, we always work with languages. So we talk not about realities, which are something out of our communication, but we talked about classifiers which are on the level of languages. So we see here on the bottom part the huge amount of not regularized classifiers. On the right part we see in light white yellow the ones that we regularize but not constructively. For example, we reproduce seeds, other plants, domestic animals, they all are regularized. We can do them regularly but not constructively. They are all cellular dependent. And on the left part we see as a yellow regularized, constructively regularized. That means we can reproduce them not addressing or not using cellular unities. And here we see, for example, RGP problems. We know algorithms from the same class, and some negentropics, cognizers, and so on. I have no opportunity to address or explain all of them, but just to get a feel, to give some feeling. What about I will? And actually, as I mentioned, all of them was done for human cognizing. But human cognizing, and we modeled by computers, and we try it, and if we try to define cognizing independent, cognizing not human, not cellular dependent, we have to give new definitions and try to continue this line, develop this line for negentropics already, not human, but negentropics in general, which are exempted from cellular and computer dependencies. And actually, the work I am reporting is actually doing that and try to advance in that. And we have to mention here that all our considerations, human, what is it doing? Of course, they are egocentric in the sense that we rely on utilities which are inherited or learned in our lifetime. We have just perceive and we create imprints in us, perception, what is the base. We create mental systems based on the imprints. The realities, universe, and all of them are egocentric, depending or very related personal to each of us. Of course, we communalize them, and we have a common concept, language. We communicate, and understand to each other. But if we generalize the concepts, not relying to human being, we have to address to all these concepts independently from cellular being. So the core of this transition are mental systems, which we define as systems of classifiers, which for given utilities identify realities favorable or damaging these utilities to support their promotion. This definition, sorry?
You are 6 minutes over.
Okay, I will try to manage. I will try to manage my speech.
No, it's okay. I'm just giving.
I'm only worried whether I am with audience or not. So you can interrupt me and say, enough, give me the definition or something else. Okay, so mentals is a formal construction independent from cellular or other cellular dependent concepts. So we take it as a base concepts, and generalized cognizers are defined as negentropics that include energizers in the lifetime regularly and ultimately learn and organize classifiers and their systems, mentals, to identify realities favorable to or damaging of their utilities to support the promotion of these utilities, while learn by acquisition and revelation of mentals from or with communities of cognizers. I understand that it is not so in this definition you need to penetrate it, but all this presentation, the book and other material, I am ready with definitions to provide you if necessary, okay? It will be interesting. So actually, the next step, we actually argue that first, these generalized cognizers, as well as human cognizers, are sufficient to go in the depth of negentropics and understand what is in the root of negentrop, how negentropicity or cognizing arise, and whether we can use this concept to go in depth. We argue this. The next we address to physicists or to achievements of physicists. Actually, physicists like Parondo, others, argued that information and actually information and classification identified. So classification in the simple spore can originate in nature, okay? Then in our consideration and our reasoning, we show that if elementary classifiers we have already, we can chain them to the highest cognizers, to the highest cognizer comparable by effectiveness with the human one. And as a result, we can make a hypothesis or address to hypothesis that the chains, not only these classifiers can originate in nature, but the cognizers as well can originate in nature, developed up to the highest level, and as human construct their robots. So these cognizers could construct their robots, and not excluded that our cellular cells by themselves, what is the base of all cellular systems, and our cells is constructed, because we know up to now there's no question if God created us, who created the God. So maybe this line will help to go and advance in this question as well. So I will not actually concluding, I would say we reduced the problem human universe and show that combinatorial game can be good adequate model for them. Second, we show that all this we demonstrated and argued that all our all these talking about to define and research generalized constructive, they are constructive, they can't be repeated. And we then, as a cognizer, generalized cognizer, which on the early stages, we argued that this, we name them OSTOFs, and these OSTOFs can be proved that they coincide with Piaget's main factors for development of cognizing. You know, Piaget using a few rules, 4 rules, and by these 4 rules, he explaining all development, human cognitive development. So this statement is important to try to formalize and bring to modeling this Piaget very important statement. And I already says that another consequences will be that to enlighten our origin. And finally, I have in my paper a lot of synergies with contemporary works which relates to the work, and actually they are in linguistics, in physics, and so on. So sorry and thank you for your patience and listening to me. Thank you very much. Are you with me?
Thank you. We are with you. I keep forgetting to turn on the microphone.
No. Aha. Okay. Okay. So that's just minimal mistake. Important is that my microphone is working.
It's very interesting. This comes back to the same question I've asked you 100 years ago on another topic, uncertainties.
Yes.
What do you do with uncertainties?
Elisa, you as a physicist sure give the more core question. You know, entropy, uncertainty in probabilistic sense. Of course, I will restrain to comment that, but entropy as a physicist, understand that.
I'm
sure,
aware of
that is, we can interpret entropy, entropy as a maximal uncertainty, because when we have no construction, no regular things, actually that is situation where we cannot fix our attention. Okay, so in this sense, they are there's some correlation between them, but I think uncertainty have a strong definitions in probability theory, and we have professionals in the field. But I see very some links. Sure, probability is one of the formalization of this, one of formalization related to entropy. Okay. And we know entropy is entropy and not entropy is defined as a mathematical expectations of expected signal or information that we expect from some source. So there's some correlation, evident correlations. Okay. Yeah.
Yes.
So I have paralyzed all listeners, and they are tired.
Yeah.
So I understand all of them. I would repeat. So those who are interested in the question, with pleasure, I will provide an electronic copy of our works and even the rest. Thank you very much.
Any other questions?
No question. No question. Only I want to say that I am going to buy your book. Thank you.
No, who is that?
I am Tigran Gevonzian.
Ah, Tigran. We can. You see, my book is in a very, say, restricted copies, but I think maybe you will have an electronic copy. But if you are insisting, you can get with my just introduction. You can get from our library.
I think we have to bring together informatics, mathematics, and biologists, human medicine, and to speak with one language.
You see, my language which I am using is very, say, I know you are interested in working in biology and modeling that, but for the beginning, I would advise you to get electronic copy. And if you don't mind, I will forward you my electronic copy if you like it very much. So we will talk about the copy.
Very nice. It will be Bible to read in bus,
don't
in bed.
Don't price until you didn't see, because it is terrible book.
Thank you.
Okay. Okay, we see that we already finished our session. Elisa, you are completing, say you, yeah. Okay, we are together, yes. Now I switch. You cannot start your video because the host has stopped it. I don't know why host stopped me, but anyway, you cannot see me, but thanks to God, you're listening to me. So I have to thank all participants. I think we had a good session, okay? We had the participants almost covering not all of the world, because Africa, Australia were not presented here, but we have from North America, from Canada, we had a voice from French University, Russia, Georgia, and sure from Armenian. So thank you very much to all participants. I hope that we will have new opportunities, and this session was useful for all of us. Thank you very much. Maybe some participants like to make a comment, Elisa or others.
No, the comment is, I totally agree with you. It was a good session, very interesting stuff.
Yes. Okay, from Georgia, from Russia, so Samara, no voice?
No comments, except the next session is supposed to start in 2 minutes. Is it here?
Yeah, okay.
So we need to make it, we need to do something about the next session.
Okay, okay. Goodbye.
Bye.
And next our meetings. Elisa, be in touch with me. Oh, yeah.
Hello, everyone. Do you hear me? I just want to test if you hear me well.
Yes, we hear you.
Great. So wish you good time until we will start our session soon.
Արդու դեմքը ոնց ես տեսնում, շատ մութ է։ Մտնեց, հա։ Չէ, մտնեց։ Հələ մի վարքյան դու հետևի ֆոնից են կոմ գնա, հենց գնում ես դզվում է, գիտես։ Հենց դու կանգնեցիր ինքը Ահա, տես, հա։ Հա, դե չէ, սենց լավ չի։ Ինչ անենք, все-таки կարող ենք կոմ փոխենք։ Դու խոսում ես, մենք քեզ չենք լսում, քո ձայնը անջատած է։
Չէ, հեսա։
Ահա։
Ես ուզում եմ փորձեմ հիմա պրեզենտացիան։ Փորձեմ հեսա մի հատ շեյր տամ պրեզենտացիան տեսնենք ոնց է, քանի բանը։ Так. Այստեղ կա։ CSIT. Ռոբ, երևում է հիմա։
Հա, երևում է։ Նորմալ երևում։
Այստեղ կողքից պետք է ներքևը ես էլ երևամ ու պրեզենտացիան։
Այո, դες ինչ-որ մի տեսակ կտրած ձևի երևում ես։
Հա, բանով էլի, առանց ֆոնի։
Հա, հա, նորմալ երևում է։
Ահա։ Okay։
Շատ լավ է, ամեն ինչ շատ համձենը, ամեն ինչ իդեալն է կարելի ասել։ Դու մեր ձենը լավ ես լսում։
Հա, շատ լավ։ Ահա, սենց որ գնում է, նորմալ սլայդերը փոխում է։
Հա, նորմալ, լրիվ։
Շատ
Մի քիչ տեղ նկարները բան ես անում, գրածները, բայց դե դե հետ, մի երկու հատ կտրում է։
Ինչ անում։
Քո նկարը ոնց որ տեքստի վրա է դուրս գալիս։ Այդ հետ, հա, մի փոքր մասը ներքևի մեկ-մեկ։
Կարանք փոխենք դա։
Էն էլ որոշ սլայդերում, չէ, մի ձեռք։
Ցել կարանք դեպքան, հա։
Ահա, всё, լավ է։ Շատ լավ ամեն ինչ։
Այսինքն։
Ընտիրա, всё, ամեն ինչ նորմալ է։
Всё, okay։ Stop tank։
Շատ լավ է։
Stop share, всё։
Ժողովուրդ, եթե վերջ
Artur?
Ռոբջան, ես առաջարկում եմ սկսենք արդեն, էլի, որտեվ աղի ժամանակ անցավ։ Լսում եք, Ռոբ։
Այո, լսում ենք։
Եթե հնարավոր է, ուզում եմ խնդրեմ հրավիրեք հյուրերին, թող մասնակիցները գան, արդեն սկսենք, էլի անցկեսա։
Արչան, հրավիրենք չեն կարա, որտեղ սաղ գնացել են, տարածքում, շենքում, չգիրենք որտեղ է։ Կոֆի բրեյք են անում երկրորդ հարկում հավանաբար։ Երևի հեսակ բարձրանան։
Հասկանում եմ, հիմա 10 րոպե անցավ։
Դե պիտի սպասենք, ինչ անենք։ Չգիտենք որտեղ ով է ուզում գա, ով չէ, ով են
Ով
մասնակիցները։
կմիանա, հետո կմիանա, մենք կարող ենք մի 5 րոպե էլ կարող ենք սպասենք, բայց եթե այնտեղ հայտարարվի, որ սկսում ենք այսինչ ժամին, լավ կլինի, էլի, որտեղ ունենք ինչ-որ։
Հա, երևի արժի մի հատ հայտարարել շատ ու իսկ ով որ ներկայացնող է, գոնե on-line հիմա կա, թե ով որ սկսելու է։
Դե եթե մեկը չլինի, ուրիշը կներկայացնի հերթով կգնանք առաջ, էլի։
Հա, ну тогда դու մի հատ ճշտի հիմա ով միացած է, մի հատ ճշտի իրանք գոնե կարան սկսեն, եթե ուզենան, էլի։
Ես տեսնում եմ Համլետ Մելաձե, Վաստուրեն դուք միացած եք, այդ մի Վաստուրեն ելույթ, այս Ռուսաստանի Ելենա Զամյատինը, Յարոսլավ Կիրիլով։
Ստեղ կային մի քանի հոգի, բայց իջան։
Երևի այդտեղ են իրանք։ Չէ, այստեղ էր միացած։
I'm here.
Oh, yes. Very good. Thank you. So you are ready to
Our
present
report
your
is the
work.
second one.
Yes, but if you don't mind, we can ask you to present first, if you are ready, because the first, or we can see how it is better.
First?
If it's not problem, I can suggest maybe on Russian talking, because all understand Russian. I don't know if you prefer.
Сейчас подойдут, наверное, остальные участники. Да, конечно. Да, никаких проблем, я думаю, не будет. Мы это...
А я так мучилась, все переделывала на английском.
Ну, я думаю, что большинство будет в состоянии воспринимать на русском, так что мы сейчас это обсудим, когда участники соберутся.
Хорошо.
Как удобно, так и можем сделать.
Мы сейчас попробуем позвать участников, найти.
Да, хотя бы, чтобы 35 минут, начать.
Хорошо, хорошо.
Потому что минут 20 уже получается, или?
Угу. Я только что вернулась с юга. Вчера прилетела ночь, а сегодня уже в Армении.
Очень приятно. Я немножко посмотрел вашу работу, пока мы не начали, хотел кое-что спросить. Фактически достаточно давно у вас это триад, вот эта программа, которая она позволяет моделировать, она давно достаточно существует, да? Да,
давно существует.
Очень интересно.
Она существует давно, но как бы коммерческой поддержки нет, и приходится, мы работаем со студентами, студенты поработали, ушли. Студенты поработали, ушли, мы какой-то шажок сделали, и все.
Да.
И потом все снова.
Да, это нам знакомо. Это трудно.
И потом у нас провинция еще, ведь все-таки Пермь-то. Народ уезжает в Москву, в Ленинград, за границу. Да, у нас давно существует. Он достаточно интересный.
Да, интересно, что этот язык фактически триады вы сами, да, разработали его?
Да, это вот мой шеф Миков, но у меня там ссылка на него есть. Он сейчас живет в Краснодаре, вот мы как раз оттуда сейчас вернулись. Он сейчас живет в Краснодаре.
Я еще заметил, у вас в 2019 году там на пермском сайте Академии был это про Фанет статья похожая.
Про Фанет, да, была статья. Да. Но только нет, она не очень похожа, потому что там не было интеллектуального
Высшая школа
агента.
экономики там вот на этом сайте была опубликована.
Да, но там не было, видите, интеллектуального агента.
Понятно.
А тут самое это главное, это интеллектуальный агент. Вот ведь, ну вот, который мы разработали, вот сейчас как бы показано, как с помощью нашего языка, встроенного Triad, можно организовать вот интеллектуального агента на базе, вот с помощью модели продукционной. Вот, а потом еще у меня есть одна работа. Там мы взаимодействие роботов делали, и там уже на основе антологий сделано интеллектуальный агент.
Интересно.
Да, мне тоже понравилось. Я давно хотела его сделать. Удалось только сейчас. А вот там вот у нас интеллектуального агента не было, там реактивные агенты просто. Вот уже агентно-ориентированное моделирование. А у вас вы моделированием занимаетесь?
Нет, лично я немножко далек сам от этой области, но у нас есть специалисты, но, честно говоря, не знаю, насколько сейчас что происходит в этой области, я сам не в курсе.
Ну, можно у меня это готово. Можно я представлю.
Знаете, мы просто сейчас ждем, пока там, поскольку перерыв опоздал, люди спустились на кофе-брейк, и сейчас вот наш коллега спустился, чтобы предупредить всех, что мы начинаем сессию, и надеемся, что сейчас поднимутся. Еще пару минут подождем, да? Если вы хотите пораньше представить, пожалуйста, можете сказать, можем послушать вас в начале. Ну, желательно было бы, чтобы мы начали сессию побольше, чтобы людей было, и потом...
Окей. Когда вы скажете, я тогда начнем.
Несколько минут, ну.
Я к вам так хотела приехать, но мне не удалось, потому что только вернулись из юга, и вот сразу я бы не смогла. Перелет был тяжелый.
Бывали вы у нас в Армении?
Нет, еще хотела. Очень просто мечтаю об этом.
Ну,
Я все
надеемся,
силы
что
положила,
получится.
чтобы написать статью. Но тут вот как бы наложилось все.
Надеемся, что получится хотя бы в будущем.
Ну, хотелось бы, да.
I think we will start within few minutes because my colleague just told me that they are finishing the break there at another floor below. in the building and participants are moving towards the session. So we hope to have more participants and start soon. Sorry for this delay, but it was not because previous session ended later. Извините, Елена, если я предложу вам в начале выступить, удобно будет, да? Потому что я думаю, что если не против будет гостей, хотим пригласить в начале выступить. Вы, а потом наши гости из Грузии. Как по списку, ну, как бы первую тему назад можем отодвинуть.
Я уже выступал, от меня не зависит. То есть для меня все равно другие что скажут.
Артурджан, сейчас поднимутся уже все.
Господин Петросян, здравствуйте.
Сейчас придут.
Добрый день, добрый день. Я спрашивал Елену Замятину, если вы меня слышите сейчас, Елена.
Я вас слышу.
Да, вы можете, удобно вам, если вы будете первой выступать?
Давайте попробуем.
Ну, сейчас вот подождем, уже собираются участники. Просто я так думаю, что предложить, чтобы наши гости...
У меня только презентация сейчас на английском, а говорить мне лучше по-русски. Не страшно.
Я думаю, что сейчас это предложу всем и думаю, что это будет нормально.
Угу.
Robert, do we expect more participants to come or we can start?
I think yes.
I think you will come.
They will come soon. Արտյան, սպասի մի հատ էլի խնդրեմ գան։ Աստին հա բարձանում ենք ու մնացի։ Սպասի։ Артян, мы можем начинать. Если придут, придут.
Okay. We warmly welcome all of you to our relatively small, but anyway, truly international session on telecommunication and networking. My name is Preperation. My colleague Robert Tadevosyan and I will moderate this session. As you can see from the program, we have 6 papers presented here in this session, and 2 of them are from our foreign colleagues and others from local participants. And as you can see, according to the program, we have about 20 minutes reserved for each participant. But I'm very sorry that we have started lately because of previous session. And we will try to fit into the time. Although program committee has put my colleagues' paper first here, following the principle of hospitality, I would propose our foreign colleagues to present their work before us, if they are ready and if they agree. So first of all, I invite Irina Zamyatina to present her work and her colleagues' work, modeling ad hoc networks using reasoning agents. Если удобно, Ирина, вы можете представить свою работу сейчас.
Yes, of course. Да, хорошо. Сейчас я...
If no one has objection, we can ask Elena to talk in Russian, but presentation will be in English. I think it will be easier for her.
Итак, я хочу представить наш доклад, который называется «Моделирование ad-hoc сетей с использованием рассуждающих агентов». Авторы работы Елена Замятина, я являюсь доцентом кафедры информационных технологий Высшей школы экономики. И здесь у меня еще мой соавтор Ярослав Кириллов. Ну, я, кроме того, как преподаю в Высшей школе экономики, преподаю еще в Пермском государственном университете, поэтому мой студент Ярослав Кириллов из Пермского государственного университета. Вот. Далее на слайде представлена outline, то есть вот содержание нашего доклада. Это не что иное, как мотивация. Потом работы, которые имеют такое же решение, подобное решение. Дальше идет алгоритм маршрутизации. Потом речь пойдет об агентном моделировании. И в конце концов я представлю интеллектуальный агент, который был разработан на внутреннем языке нашей системы моделирования, которая называется Dayd'e. Dayd'e говорит о том, что у нас есть трехслойное описание имитационной модели, а NS – это не что иное, как сети, коммуникационные сети, компьютерные сети. Итак, в настоящее время мы знаем, что развиваются технологии интернета вещей, развиваются технологии, связанные с умными городами и с умными планетами, с умной планетой и так далее. И все это вызывает необходимость в надежной доставке сообщений от одного узла к другому узлу компьютерной сети. Вот. И в связи с этим появилось большое количество различных алгоритмов маршрутизации, а также появилось огромное количество различных сетей, в том числе и самоорганизующихся сетей, а именно, ну вот, как тут написано, ad hoc networks. Вот. И возникает необходимость в том, чтобы можно было разработать и воспользоваться именно эффективным алгоритмом, который должен быть энергосберегающим, с одной стороны, а с другой стороны, надежным, чтобы доставка сообщений была четкой. Была необходимость в том, чтобы он был недорогой, этот алгоритм. Вот. И в связи с этим возникла необходимость вот в исследовании таких алгоритмов маршрутизации. И при исследовании это не что иное, как сложная динамическая система, сложный динамический объект. И известно, что такие сложные динамические объекты чаще всего можно исследовать с помощью имитационного моделирования, с помощью методов имитационного моделирования. Вот. Далее представлены вот здесь вот ad hoc сети, значит, характеристики ad hoc сетей. И вот у нас уже были работы, связанные с ad hoc сетями. В частности, у нас были публикации, связанные с такими ad hoc сетями, как Fanet, Manet. Вот, то есть мы попробовали их исследовать. И для исследования мы хотим применить вот нашу разработку системы моделирования Dayd'e. Как я уже сказала ранее, Dayd'e – это система моделирования, которая строит имитационную модель, состоящую из 3 слоев. Это слой структур, где описываются узлы вычислительной системы. Это не что иное, как слой рутин. Слой рутин позволяет нам описать поведение объектов сети. И это не что иное, как слой сообщений. Слой сообщений используют для описания сообщений сложной структуры. Вот. Ну, наряду с нашей работой, естественно, есть и другие симуляторы. Вот тут представлены симулятор Omnet++, вот это NS3. Но вот что касается, кроме того, значит, существует еще симулятор такие, например, как AnyLogic. Ну, AnyLogic, он охватывает не только компьютерные сети, не только предназначен для исследования компьютерных сетей, но и бизнес-процессов, ну, в сроке охвата у него предметов для моделирования. Мы вот как бы настроились на компьютерные сети. Так. Ну вот здесь вы видите как раз на экране, это не что иное, как графический редактор нашей программной системы Dayd'e. Ну и дальше в статье представлен протокол DSR. Это не что иное, как реактивный протокол. Он широко известен. Вот здесь здесь показан алгоритм. Этого алгоритм этого этого протокола. Вот. Но я не знаю, стоит ли там сейчас погружаться в него. Если что, я его потом объясню, как он действует. Вот тут представлен пример. Вот. Но дальше хотелось бы сказать следующее. Вот существуют различные парадигмы имитационного моделирования. Это событийно-ориентированная, процессно-ориентированная парадигма, и есть агентно-ориентированная парадигма. И вот наиболее подходящей парадигмой для исследования алгоритмов маршрутизации компьютерной сети является агентное моделирование, потому что каждый узел вот этой компьютерной сети может быть представлен отдельным агентом. И вот как бы основной смысл вот нашей работы это не что иное, как попытка создать интеллектуального агента. Зачем мы создаем интеллектуального агента? Известно, что вот устройства, которые используются в настоящее время в компьютерных сетях, они становятся все более интеллектуальными. То есть устройства являются адаптируемыми. Они адаптируются к условиям, которые создаются в компьютерной сети, и каждому узлу приходится принимать решения. В связи с этим мы решили разработать агента, который позволяет действительно принять какое-то решение в связи с теми условиями, которые создаются в компьютерной сети. И мы сделали модель, мы использовали модель знаний, это продукционная модель знаний. И вот в этой работе, в этой статье как раз мы демонстрируем работу агента, который построен на продукционной модели знаний. На самом деле мы ведем и другие работы, и в другой работе там используется уже другая модель знаний, а именно модель знаний, основанная на семантических сетях, и модель знаний, основанная на онтологиях. Вот. Ну и далее представлена, значит, в нашей системе моделирования TRIAD-NS существует внутренний язык. И вот синтаксис этого языка представлен на вот этом слайде. На этом слайде показано, значит, синтаксис рутины, то есть мы здесь описываем поведение агента, то есть интеллектуальная рутина, дальше указывается имя этой рутины, дальше указывается описание полюсов, то есть входных параметров для этой рутины. Дальше еще идут настроечные параметры. И дальше секция инициализации, описание событий и правил. Поскольку у нас есть интеллектуальная рутина, которая основана на знаниях, на продукционных правилах, нам необходимо указать, во-первых, факты и правила. Факты и правила мы описываем вот в секции инициализации. Ну, а дальше вот уже механизм вывода, он описан здесь. Вот описаны правила, как они записаны. Ну, например, правило Правило это лето. Если у нас текущий месяц 6 или 7 или 8, то тогда мы планируем schedule start vacation. Ой, переключилась. Start vacation, то есть у нас начинаются каникулы. Мы планируем события начала каникул. Ну, а здесь объяснение. Ну, поскольку у нас сейчас июнь, июль или август, то мы можем планировать вот как раз начало каникул. Ну, здесь представлены классы, которые у нас описаны в компиляторе. Еще интересная вещь, которая связана с системой Triad-NS. Вот в нашей системе Triad-NS для того, чтобы расширить ее, используют антологии. То есть у нас есть базовая антология, которая описывает базовую структуру системы моделирования Triad, базовые рутины. И если мы хотим расширить функциональность нашей системы, то мы как раз делаем подклассы в нашей антологии. Вот здесь как раз сделан подкласс для интеллектуального агента в слое структур и дальше в слое рутин. И таким образом мы расширили функциональность системы Triad-NS, включили интеллектуального агента. Здесь на этом рисунке представлена структура агента. Здесь далее представлено вот наложение рутины, то есть мы выбираем какой-то объект, и на любой объект можем наложить рутину, то есть приписать некоторое поведение нашему устройству. Вот. Далее представлено уже для протокола DSR правила. И результаты. То есть вот протокол сработал правильно, и с помощью подсистемы анализа нашей системы вот как раз представлено, опять же, результаты. Значит, информационные процедуры у нас анализируют работу имитационной модели, и вот тут указывается, что узел 3, например, получил 2 сообщения, узел 5 получил 1 сообщение, узел 4 получил 3 сообщения. Ну и вот результаты моделирования показали, что интеллектуальный агент работает верно, и можно пользоваться системой моделирования Triad-NS для моделирования для моделирования протоколов, в которых используются узлы, которые могут принимать решения. Вот, на этом я свой доклад заканчиваю. Спасибо за внимание. Я жду вопросов.
Большое спасибо за ваше участие, за интересную презентацию. Пожалуйста, вопросы. Thank you for interesting presentation. Any questions?
У меня вопрос, если можно.
Да, давайте.
Да. Скажите, пожалуйста, вот как бы вот это, ну, как бы вот меня интересует интеллектуальная часть организации работы reasoning, using reasoning agents. Да, по существу ваши агенты они просто анализируют ситуацию в сети и принимают соответствующее решение? Или могли бы
Да.
сказать более, несколько подробнее? Вот в чем, как вот с чем можно сравнить, какой анализ они проводят?
Ну, они анализируют факты, вот как в классической
Ну что,
продукционной
вот
системе.
интенсивность, какой-то трафик или что? Вот какие параметры являются входом и выходом этих агентов?
Входами и выходов этих агентов. Ну, вот тут представлены, например, вот этот алгоритм DSR, и он получает разные пакеты. Вот, например, пакеты рэп, другие пакеты получает он, еще RREC и так далее. Ну и в зависимости от того, какой пакет он получил, и в зависимости от того, получил ли он этот пакет повторно или нет, он принимает то или иное решение и отправляет дальше пакет.
То есть решение по маршрутизации, да, по существу более интеллектуальный маршрутизатор, да, вот так можно понять?
Да.
То есть решения касаются того, по какому, скажем, пути послать в зависимости от того.
Да, именно так.
Да. Но в современных системах разве аналогичные вещи не делают? Ну, как бы они встроены, такие алгоритмы есть?
В современных системах имитационного моделирования этого...
Нет, в современных сетях по существу маршрутизаторы, они по существу реализуют нечто подобное? Или я не утверждаю, я просто спрашиваю.
Может быть, они и реализуют, но ведь их надо исследовать.
В этом плане, то есть вы концентрируетесь на моделировании этого и дальнейшем,
именно так.
То есть у вас вопрос адекватности модели стоит.
Да, то есть мы как раз как бы делаем цифрового двойника.
Да, понятно. То есть у вас по существу здесь вопрос адекватности модели и дальше работы с ней.
Да, именно так.
Спасибо.
Спасибо, Эдуард Мусесович. Thank you. Any other questions?
Можно? У меня есть один вопрос.
Да,
на основании чего делается, или создаются эти критерии маршрутизации? Что является, не знаю, параметром этих критериев? К примеру, вот в сетях обычных IP-адрес есть такое понятие, как таблица маршрутизации. А что здесь является в этой модели этим критерием?
А здесь другой протокол. Вот вы говорите про активные протоколы, а я говорю про реактивный протокол. И вот здесь вот я говорю, что может быть разное поведение узла. То есть он может послать по одному адресу пакет или другой пакет он может послать. И, собственно, даже не вот этот вот алгоритм маршрутизации DSR, а на будущее, ну вот то, что сейчас вот эти устройства, которые в IoT и в умных городах и так далее, в общем, в сетях телекоммуникаций, они становятся более интеллектуальными, это факт. И для того, чтобы создать такой алгоритм и проверить его работу, нужны вот именно средства имитационного моделирования. И мы как раз их предлагаем. Именно цифровой двойник для того, чтобы можно было проверить работу интеллектуального узла вычислительного. Неубедительно?
Да, спасибо.
Спасибо, Роберджан. Тут разница в том, Роб, что речь идет именно о реактивных протоколах, то есть DSR — это Dynamic Source Routing, то есть речь идет, как я понимаю, о том, что это самоорганизующиеся сети,
Да,
правильно?
самоорганизующиеся
И
сети.
у них другой подход к маршрутизации.
Да.
Я понимаю, что другой подход, какая-то логика другая, но что является критерием определения маршрута? Что за параметр берется вот в этом вопросе? Или на основании чего решается, к примеру, вот так или так отправить? Только в этом был вопрос.
Ну, вот в настоящее время вот в самоорганизующихся ad-hoc сетях очень часто делается акцент на том, что надо выбрать такой маршрут, чтобы он был энергосберегающим, например. Это просто пример. А для того, чтобы он был энергосберегающим, там надо проверить, сколько энергии, достаточно ли энергии у того или иного узла. И вот выбрать именно тот маршрут, который позволит осуществить надежную доставку сообщений.
Знаете, извините, но мне кажется, что вот я специально заострил. Вот задача поставлена построить адекватную имитационную модель. А вот то, что они пишут, reasoning и так далее, это предмет отдельного исследования, который, мне кажется, в работе не рассматривается. То есть, на самом деле, там нужно посадить эксперта тогда или его аналог, который будет и критерии, и все, как человек это делает при выборе маршрута, постараться приблизиться к его, по крайней мере, решению. Вот так. То есть, заранее сказать, по каким критериям это будет. Вот здесь как раз это избегают, reasoning, то есть это должно быть пока рассуждение. Вот ввести механизм рассуждений, по которым и будет принято решение. Мне кажется, вот нечто такое.
Вот как раз этот механизм рассуждений мы и вами предлагаем.
Вы по существу рассказали про то, я так понял, что как имитировать модель все это, а как будет этот механизм рассуждений работать, это отдельный вопрос.
Нет, он будет работать как экспертная система.
Надо сделать это. Я понимаю, что она должна приблизиться.
Нет, у нас-то это сделано.
У вас это сделано. Тогда вопрос Роберта очень резонный. То есть, как он, по существу, расскажите о том, как он принимает решение. Как реально reasoning осуществляется. То есть, это общая ведь проблема, на самом деле, проблема рассуждений. Типичная проблема в этих системах. Как рассуждение, как вообще, это логический вывод, какой-то вывод.
Да, механизм вывода работает.
А как вот это у вас это есть в работе или как-то?
В работе есть, там приводится пример.
Пример приводится, но так общего описания нет.
Почему? Это как...
я спрашиваю, я не потому что... Может есть, а может нету.
Это просто как бы обычная экспертная система, по сути дела,
Вы знаете,
получается.
просто правила, там обычные экспертные старые системы, они rule-based, то есть влево, если что-то такое, делай так. Это все могут быть и встроенными. Но когда мы говорим о reasoning сегодняшнем днем, то тут имеется, конечно, намного knowledge-based и вообще на знаниях основанные, но это очень сложные вещи. Поэтому просто как старые экспертные системы, они просто правила...
я не знаю, старые, не старые, но...
я имею в виду, это так, rule-based. То есть там они if then, if так, то делай так. Если так, то это просто начальная система. А сейчас все же reasoning слово более такое. Ладно, спасибо.
Нет, я же говорю, что мы на самом деле работаем не только этот пример, это основанное на продукционной системе, продукционной модели знаний.
Продукционные системы, они про существо rule-based, они это и есть, rule-based systems, то есть основанные на правилах.
Основанные на правилах, да. А есть еще у нас новая работа, основанная на антологиях.
Антологии, это, понимаете, это тот понятийный
Ну, связь с
понятийное
семантическими
поле,
сетями.
в котором эксперт работает. По это понятийное поле вы можете получить, что онтологию можете построить. Но как с этой онтологией дальше действовать и как ее использовать для того, чтобы в результате было бы принято как приемлемое решение, это очень непростой вопрос. Я это говорю не так со стороны, непосредственно, вот если посмотрите работы, наши две работы из нашего института, значит, они непосредственно относятся к этой тематике. И это очень непростая сфера. Ну, во всяком случае, нам очень интересно, как вы решаете. То есть переход к онтологиям – это один из шагов. Это частичка, компонента всего этого. А как знания включать в дело и насколько эффективно – это очень непростая проблема.
Ну, вот эта другая работа, вот, она связана с взаимодействием роботов. И вот там мы как раз использовали на взаимодействии роботов, мы как раз использовали вот уже такой прием, как из агентов, основанных на онтологии.
Это в Пермском институте или в Москве, в высшей школе экономики?
Да нет, у нас, Пермский университет, это во-первых, во-вторых, у нас есть филиал Московской школы экономики.
Это в Перми?
Я работаю в этом филиале, да.
Это в Перми, да, в Перми?
Да, в Перми работаю.
Школа высшей экономики, да, понятно.
Да, да, высшая школа экономики, я работаю.
Да, да, знаю. Спасибо.
Спасибо большое. Есть другие вопросы? Any questions? Any more questions? Если нету, мы очень благодарим вас за выступление. Thank you very much for participation. And we can move to next our participant. Paper from Georgia. Amlet Meladze, Revas Kakubava, Lela Trapaidze. Closed and mixed type queuing models for structural control of complex technical systems.
Thank you. Hello, everyone. I'm just sharing. I'm Lela Trapaidze from Georgia, from Tbilisi. It's Technical University of Tbilisi, and my presentation is about closed and mixed type queuing models for structural control of complex technical systems. The presented paper discusses the problem of structural control for a complex technical system and its mathematical interpretation. The closed and mixed exponential queuing model for the system dependability and performability analysis is constructed in the form of finite or and infinite system of ordinary linear differential equations. In steady state, it is reduced to the system of linear algebraic equations. The first is introduction. This topic belongs to the mathematical theory of reliability, which applies the methods and models of queuing theory, while it is investigated including dependability and performability analysis of complex system. We consider a multi-unit redundant system which repairable units such as info communication, computer and transportation networks, power and defense systems, etc. The problem is possible to formulate in terms of the practical problems of queuing theory, but we prefer to formulate it in terms of practical problems for the solution of which necessity of our research has arisen. The research topic is significance within the network maintenance problem. In Infocommunication network are an important attribute of modernity, so the problem of structural control over complex technical systems is very relevant, namely diagnostics, redundancy control, and maintenance. Carrying out structural control means ensuring the maintenance of the existing structure of the controlled object, its elements, including connections and their modes of operation. Otherwise, it is a compensation for structural disturbances. Disturbances can be of different types. We discuss structural disturbances, the compensation of which requires the organization of structural control. We should mention here the high importance of open queuing models for dependability and performability analysis of modern territorial distributed networks. The fact is that for a long period of time in MTR and QT, there was generally accepted the idea that in problem of reliability and maintenance of redundant complex system on the finite source queuing models were applicable. This idea, however, is valid for classical machine maintenance problem, but for modern network maintenance problem, open queuing models or mixed type models are mainly applied. This is verified by experts from Georgian Technical University in their publication for last years. It's in references these articles. What is a problem? Problem statement is that in the classical theory of reliability, the repairment problem is formulated as follows. Suppose we are given m identical stochastically independent units, and they are then identical and redundant units. M is more than n. Assume that each is by some distribution of lifetime. Also suppose our repair channel can repair k element. If the repair channel is busy, each new failed element unit will move to the queue and wait for the repair channel to be released. The failed main unit must be replaced by operative redundant one. Thus, if at failure moment there is a free redundant unit in the system, its replacement operation will happen. The failed units, both main and redundant ones, must be repaired. The repaired unit is supposed to be identical to the new one. We assume that the repair time are also independent, identically distributed random variables with some repair time distribution. The diagram in figure 1 will be helpful in explaining various models of repairment problem. On this diagram, it's seen. In the case, we construct the mathematical model. Let the failure intensity of one main element be alpha, while the failure intensity of one redundant element is beta. Repair time is an exponentially distributed random variable with parameter lambda. Let Pi of t denote the probability that the number of failed elements is I in the system at time t. Proceeding in the usual way, we can set up the basic difference equations which relate the probability of being in a certain state at time t plus delta t to the probabilities of being in various states at time t. From these difference equations, we obtain the finite systems of the ordinary linear differential equations. We have finite system of ordinary differential equations. consider a queuing system operating in a stationary state. Denote pi equals to limit as t approaches to infinity, pei of t, and we get this in these conditions. We get the system of linear algebraic equations together with the normalizing condition. How is mathematical model for when m equals to infinity? The classical mathematical theory of reliability doesn't allow to solve the problems of dependability and performance analysis of large-scale territorial distributed networks. For these purposes, further extending the development and deepening of classical repairman models are necessary. We give an explanation of a specific example. The number of radio base stations in modern mobile communication networks may be hundreds, thousands, and more. That means that in mathematical models we can consider that set of RPC as an infinite source of failures. Due to the same factor, we can consider the total failure rate to be constant. Consequently, we will have a Poisson stream of requests to maintenance facilities. As it is known, this is very important for the construction of suitable mathematical models and also for their investigations. And figure 2 shows interpretation of the repairman for a problem considering for this factor. This is the diagram, figure 2. In this section, we consider the case when m is a large number. This m is a very large number. And we will suppose that we will have an infinite source of request and we will get an open queuing system. We construct the mathematical model for the case when m equals to infinity, n is arbitrary. The total failure intensity of main elements is alpha, while the failure intensity of redundant element is beta. Repair time is exponentially distributed one random variable is parameter lambda, and we get ordinary linear differential equation systems of differential equations. This is a system, and if we denote pi as a limit as t approaches to infinity of pit, we get linear algebraic equations with respect to pi. In this system, from this system, we get to the linear algebraic equation system, and there is normal condition. And the existence of a solution to the system of equations uniqueness and the task of constructing an approximate solution require special consideration, and in this article we will not touch on this case. We will refer only the relevant literature. We consider infinite number of service channels. Organizations around the world are looking for new approaches to maintain, increase their competitiveness. Maintenance outsourcing is one of the methods to minimize operating cost is sometimes an alternative. Consider the case where the number of service channels is infinite. By using outsourcing, this source is also infinite. Any application immediately starts the service. There are no queues. The intensity of the failure is alpha. The intensity of the repair is mu. The system of differential equations we have before this form. And from here we get algebraic equations in stationary position. And we from these equations we get this solution. And at the conclusion, I'm saying it is known that our production of an object and the quality of the output products mainly depends on the quality of its coordinate and parametric control. But the integrated solution of the facility is determined by its reliability and consequently by the level of its structural control organization. It can be said that the degree of coordinate and parametric control is revealed instantly, and the quality of structural control over relate to long interval of operation. This structural control of complex system is a strategic problem, and its solution requires the development of appropriate specific methods and tools. The implementation of the principles of quality and the reliability of complex technical facilities allow the effectiveness of technical systems to be assessed by analytical methods during both design and operation. We discussed the closed and mixed exponential queuing model for the system where incoming stream is a Poisson flow. Under such condition, the system is described as Berthi's Markov process, reconstructed in the form of finite and infinite system of differential equations. There are references. Thank you for attention.
დიდი მადლობა თქვენი მონაწილეობისა და საინტერესო პრეზენტაციისთვის. Thank you for your interesting presentation. Thank you very much. I know Georgian a little. Any questions, dear participants?
Thank you very much.
Any questions?
I'm very glad for your comment.
Personally, I do not have questions because it's not my area, but I hope there will be questions.
I want to say I don't know English well, so it's okay. I'll answer your question by mail. May I do this?
Можно мне вопрос, да? Вопрос
Yes,
можно?
please, yes.
Да, у меня вопрос к госпоже Леле. Я как понимаю, это ваша будущая докторская диссертация, правильно?
Да.
И было бы хорошо, если вы отделили бы именно ваш вклад, в отличие от, допустим, работы других соавторов. Что именно вами сделано? Вот, и что именно в этой статье вот, нового такого?
Это моя часть, это последняя часть, где это у меня была about outsourcing, об outsourcing было там разговор, когда source is infinite, когда этот maintenance maintenance is infinite. Sorry, sorry. May I by mail say this answer of this question?
Okay, thank you. Anyway, you can take this question as a recommendation.
Okay.
Thanks for the question.
Thank you.
Any other questions? If there are no questions, again, we can thank Leila and thank you for your presentation. We can move on to local participants, and we now have Lila Husikyan and Armen Avazyan with the paper entitled Mobile Network Energy Efficiency Improvement by Power Saving Functionality. Do we have the presenter here? As far as I understand, maybe the authors are not present. Yes, Robert?
Yes.
Yes, okay. If they are absent, we are moving to the next presentation. Timur Jambaryan, Network Infrastructures Assessment Stability.
Hello, everyone. My name is Vahagn. Actually, I worked with Timur Jamgaryan on all of this stuff. So he is ill. I'll present this topic for you. So let's start. We both are students in National Polytechnic University of Armenia. Actually, the theme is the network infrastructures assessment stability. So as the opposite one that did our Georgian colleague. So the first one, the relevance of the work to deploying and operating a network infrastructure. There are often situations in which the change one or another element, including in the network, can lead to a violation of stability. That's not optimal. Second part, the situations in which, in relation to which it's required to make changes, grows with the increase of the set of elements, including in the network infrastructure. And the third point, as a rule, the member of the single criterion elections, is small. Mainly, the number of the elections is multi-criteria. The object of this study is a configurable data network for limited time. So, formulation of the problem: to develop a model for assessing the stability of network infrastructure with multi-criteria optimization. 3 tasks: form a multi-criteria model of the network infrastructure and stratify it. Develop a method for assessing the accuracy of stratification of a multi-criteria set. The third point is develop an analysis scheme based on selected method. A couple of terms that we used. First one, Pareto rule. It's 20-80 principle. That means that 20% of effort is bringing 80% of result, and remaining 80% of effort can only bring 20% of the result. Second point, network infrastructure is a collection of special equipment and software that creates a basis for effective information exchange. Decision maker, a person who makes choices and carries full responsibility for its consequences for his decision, his or hers, sorry for that. And Lyapunov's theory of stability is used as a tool for assessing the stability of a network infrastructure. So about our model, multi-criterial network infrastructure model. The first point is like R first, second, R nth, like R many criteria of system elements. In our words, is hardware. The second point differs until the end, many declared system criteria, parameters, protocols, algorithm, and what we are using, etc. G, many criteria for undefined system states. The first until the end is the backdoors. And T, many criteria topology system states in like a full, it's divided in 2 points, full connected, not full connected, or hybrid connected, as you can see the reference in our topic. So, and the Q, the stability text function, it is the criteria which determines the set of all states of the system within the given measurement and at continuous time. Okay, accuracy of network infrastructure stratification for different data set. Like stratification, like checking in our words. So we've got KR, KD, KG, KT, and each one is KR, accuracy of stratification for the set of criteria for system elements, KD, accuracy of stratification of the declared system criteria, KG, accuracy of stratification of undefined of the declared system criteria, KT, accuracy of stratification of system topologies, and which all are included in stratified network structure, OKM. We've got analysis scheme. First point, a selection of elevation criteria from the whole set of criteria. Criteria is taken by OSI network layer stratification. The second point, stratification of the selected evaluation criteria, like pump it up. We are pumping up the criteria with this point. Determination of the required criterion and assessment of the degree of its impact on the network infrastructure. The definition of the stability function key. We just need to get that function. Determining the Pareto optimal set of criteria S, and assessment of the stability of the network infrastructure as a result of Pareto optimization. So we've got 3 key points. The first point, the network's infrastructure is stable in any case, anytime, no worries about anything. The second point, like we are sure that a network infrastructure is not stable. So the main like flexible point, S equals Q. The network is a network infrastructure is stable asymptotically. It means during the time we are checking, it is stable, but out of that, we are not sure. We've got 2 examples. The first one is calculation of the stability of the network infrastructure for Pareto optimal distribution of the set R. We've got stability with the question with the equation Q equals 1 plus T minus X. For the second, any non-negative Pareto optimal solution for giving multi-criteria dataset will be optimal. The first point, as I mentioned in previous slide, S is stable, T is equals to infinity, plus infinity. That is going to be. So the second example, calculation again of the stability of the network infrastructure for Pareto optimal distribution of the set R. Q equals, we are taking the equality like this, Q equals 1 minus X in quadrat function from T. S is stable when FQ is 1, S non-stable when FQ is -1. Not in all cases, the Pareto optimal solution increases the stability of the system. So 3 conclusion points. The first one, there has been formed a multi-criteria model of the network infrastructure. Second one, has been developed a method for assessing the accuracy of a certification of multi-criteria set. Third one, a scheme for analyzing the assessment of the stability of the network infrastructure with multi-criteria optimization has been developed. I think this is all. Thank you for your patience, and we're open for questions.
Thank you very much. Thank you for your presentation. Any questions, please?
I have one question. I don't know on Armenian or on English.
Russian, maybe it's better.
Okay, it's Russian.
At least Russian.
Yeah, okay. More international. Может быть, я упустил первый момент, может быть. Конкретно в какой области применимы эти моменты или эти советы, скажем, там, которые здесь описаны, если возможно? Да.
Если позволите, на вопрос отвечу я.
Ага.
В какой области? Значит, применение, значит, до того, как ответить, небольшую такую преамбулу скажу. Мы помним трехуровневую модель иерархическую ЦСК, ядро, core, distribution, access. Главная задача, какой параметр в ядре сети изменить так, чтобы сеть не перешла именно в ядре сети, не в уровне дистрибуции или доступа, а именно в ядре сети. Какой уровень, какой параметр можно изменить, чтобы сеть не перешла в состояние нестабильности, неустойчивости. В частности, если мы помним, ядро отвечает за быструю доставку больших пакетов, за быструю доставку пакетов, размер не будем обсуждать. Вот насколько вероятно кумулятивное изменение сети. То есть мы изменяем какой-то параметр, а через некоторое время это приводит к дестабилизации. Вот в этой области. Еще, если позволите, дополню, чтобы закрыть. На этом основе, на основании вот этого всей математики разработано ПО, которое позволяет, введя в данное ПО все протоколы, все устройства, в том числе версию программного обеспечения данных устройств, потому что это очень немаловажный момент, оно позволяет на основе генеративной сети просто посчитать, когда ваша система с добавлением или с убавлением того или иного устройства или протокола, я не буду сейчас заострять внимание, объекта, потому что в работе именно с того или иного объекта сеть перейдет в состояние неустойчивости. Но хочу отметить, мы под устойчивостью понимаем устойчивость полигонова, это ограничение системы. Я ответил на ваш вопрос. Благодарю.
Вполне, большое спасибо. Очень хорошо. Да.
Any other questions, please? I have one question regarding. Могу и на русском тоже задать вопрос, если так. Вот там в статье у вас указывалось про OCI-модель, то есть там какие-то речь шла о каких-то уровнях, да? Я хотел узнать, вы рассматривали реально какое-то, вот, допустим, применение этого в каких-то реальных протоколах вот интернета, там, допустим, на каких-то уровнях, там, допустим, в IP-уровне, если IP-уровне, то конкретно, допустим, IPv6 или IPv4, то есть там же разница может быть очень большой.
Я отвечу на ваш вопрос. Значит, применение было таким. Значит, была построена, то есть она на данный момент строится еще сеть на радиомостах, я объясню. Значит, в ней были подняты VPN-туннели, в частности, VPN-туннель, на оборудовании микротик, EO-IP-туннели были подняты, и при двойной инкапсуляции, помним, что WAN интерфейс, что когда мы инкапсулируем полностью всю дейтаграмму, внутренние IP-адреса, в общем, IP-адреса все скрываются внутренние, остается только внешний, который на WAN интерфейсе. Вопрос об инкапсуляции EO-IP идет. Вот при второй инкапсуляции если происходил туннель. Значит, совмещение алгоритмов OSPF и RIP в точке на раутер, если на одном порте у нас идет RIP, на другом порту у нас работает BGP, надо как-то вот эти две локальки, две эти сети соединить, они не соединялись. Сначала мы думали, это проблема чисто конфигурационная, не можем настроить что-то. Но вопрос вырос в более глубокую проблему. В частности, EOIP не позволяло это сделать. Вот я отвечу на таком уровне. Где это, какие применительно к протоколам, это все описательно. Это все описательно. То есть мы должны понимать, что мы хотим.
Спасибо. Достаточно интересную информацию уже сказали. То есть вы реально что-то экспериментировали с реальными какими-то уже протоколами, с реальными устройствами. Ну, UIP – это речь идет о канальном уровне. То есть тут, естественно, вы получаете именно мосты, то есть одну и ту же среду. Но поверх этого фактически вот то, что вы, допустим, там говорили про RIP или про BGP или SPF, вот в применении к этому уже на IP уровне, на уровне адресации, какая адресация рассматривалась? IPv4 или IPv6?
Нет, рассматривалась адресация IPv4.
4. Да.
Вариант IPv4 версии.
Хорошо. Да, потому что в случае IPv6 там совсем другое можно получить. Нужно много чего смотреть. Интересного можно получить, что и достаточно странного даже можно получить.
Я могу, если позволите, задать встречный вопрос. Мы помним, что в IPv6 можно передавать там джамбограммы размером чуть ли не с фильм. Это позволит решить как-то проблему или нет? Потому что каждая инкапсуляция снижает MTU.
Ну, вот в этом как раз и вопрос. Это надо экспериментировать. Я поэтому говорю, это интересный вопрос.
Еще
вот именно поэтому, что тут можно как раз другие результаты получать.
Я запишу, но посмотрим. Тема для будущих исследований, так скажем.
Да, это как комментарий даже. Спасибо. Спасибо. Any other questions? If there are no more questions, we are thanking very much the participants. Спасибо большое. Mokatsian. And we have in our session 2 remaining presentations. It's about papers that are where authors are me and my colleagues. So I will try to present these 2 papers one by one. First of all, now I will share the presentation. I think you should see now the presentation. Is it okay? So can someone confirm that you see the presentation? Robert John, is it okay? Is the presentation visible?
Yes, yes.
Okay, so I'm going on. So this first paper is entitled Implementation of Acme v2 version 2 based automated centralized wildcard certificate system. And what we are talking about, digital SSL certificates are essential tools for securing network services and authenticating network servers. And most of people using internet, not maybe most, but many, understand, for example, what is different between HTTPS and HTTP, and most understand if want to use for example, if we are talking about websites, our mostly used web services, many understand that it's secure to use some website only if you are connecting via HTTPS, because this S letter means that you are connected using secure connection. And secure connection means that it was established secure connection, secure channel between your device and the web server website you are connecting. and no one in between can see the information that you are transferring from your device to the site, to the web server you are connected to. And this is only a widely spread example of digital certificates usage today. Certificates are also used in other network services like mail services and other secure connections, for example, remote access to some servers and remote data transfer and so on. For obtaining the digital certificates, previously there were only commercial solutions for public services. Of course, there already always existed a solution for self-signed certificates, but it could not be used for public services. And last several years, situation changed due to a very interesting project called Let's Encrypt. And this project provided free certificates. And after launching this project, they went further and started providing not only single certificates, but also wildcard certificates. Wildcard certificate means that you are having a certificate that is covering whole domain. So for example, if our domain is, for example, our conference domain CSIT2021, a wildcard certificate for this domain means that anything at the left and after that .CSIT.am is being covered by this single certificate. And there is no need for multiple certificates for multiple names, domain names. And based on this availability of these very important certificates, for free availability due to this project, Let's Encrypt, we have started developing our own automated system to use that. And now we have developed and implemented this centralized certificate service, which is based on this Let's Encrypt wildcard SSL certificates. So this work presents this system. As I said, the wildcard certificate means this. This slide shows this. So after domain, at the left, you can have www, email, any name. And all of this can be covered by a single certificate. What features does our system have? The system is now functioning as a centralized certificate server. So we have a single point where all certificates for different uses, for different services are being obtained. And then the certificate server provides these certificates to another service that can request and get it. And it's known that even though Let's Encrypt provides the free certificates, but they are for a very short period, and it's for 3 months that validity of these certificates is limited to. So there exists an automated renewal tool which works out of box if you are using any open source system like Linux. It's called Certbot, but we needed something more because we are using wildcard certificates and we want to provide multiple certificates for many servers. And it would be very efficient to have single tool to get all these certificates, because this as I said, ready to work certbot works only for single certificate. So you need to run it multiple times if you have many certificates to request and to get. Also, for wildcard certificates, it is ACME Automatic Certificate Management Environment Protocol version 2, which is implemented on our server. And this protocol requires also additional configuration, which was done on our server to centrally request certificate and then distribute it to multiple servers. Each server, we call them client server, web server, mail server, and so on, can get not a single, but can also get multiple certificates from central server. Here is the topologies, the architecture of our system. So we have a central server here, and this central server does all the work to request from the Let's Encrypt the certificate and get it. I will explain it in more details later. And after that, we have ready certificate at the central server. The central server itself also takes care about the renewal. So it periodically updates the certificate and always has the fresh version of certificate. Although, as we said, it has validity of 3 months only. And other below servers, as I said, clients, they can request this certificate and have a copy of it for their use. And also at the clients, we have an automated tool which periodically checks for update. So we can say that it is two-layer hierarchy. Central server does the main job, and on each client, there is a separate tool to update the certificate from central server. And this solution provides a possibility to have multiple certificates for multiple services and have it provided from central point at central server. Few words about the details of system structure. Central certificate server part mainly is based on open source solution, which we have modified and extended for our needs. It consists also about one important additional add-on, which is required by ACME version 2 protocol. It's called DNS01 challenge. It means that when you request an SSL protocol certificate, you want to get a certificate for some domain, you need to prove that you have a control for that domain. It means that you need to prove that it's your domain. And there is two variants of verifying the control you have under that domain. One version, DNS web-based version, is not being approved by ACME version 2 protocol for wildcard certificates. And that's why we have only single option, DNS challenge option. It means that if you want to request some certificate from certification authority, so-called, so it's in our case, Let's Encrypt system. If you want to obtain a certificate, you need to publish specific record in DNS. And this specific record should be under _acme-challenge and your domain, for example, CSIT2021. You should publish specific records that this system will require you to publish. All this part is implemented in our system. And for each domain that we want to get a certificate, we have a _acme-challenge dot and domain zone delegated to the central server, our certificate server. And if we want to get a certificate, or later we want to update it, we have automatic solution under this server, because it has a DNS server which provides this zone information, and it automatically publishes the required record to prove that the domain we are requesting certificate for is under our control. This is one separate part. Also, there is another functions for this system, a server part, the central server part that I will discuss in later slides. But here we can also say that distribution of certificates after they are available centrally on the server is based on the client. So server does not send certificates to clients. Central server is only responsible for getting the certificates and making them available. And we decided that most effective would be to not to push the certificate for the servers. So if I go back to the previous slide, I can explain. So this central server gets the certificates, but it does not send them to bottom servers. It only provides them possibility to connect and initiate the request and get the certificates. And it means that distribution of server certificates per client is implemented as a local process, local tool running on the separate servers, local client servers, mail server, web server, and so on. And they have their configuration, and they can request certificates that they are allowed to get from central server. And for each server, connecting server client, I mean, separated SSH public-private key peer is being registered to provide the access. So access control is per server. And it means that we can get a certificate for specific server and provide it to some server, and each server will not be able to get more than the certificate that is specifically provided to that server. But in addition to that, each server can get more than one certificates. This system I have described is currently actively used in production and provides centralized, secure, automated digital certificate server for different types of network services in our National Research Educational Network. We are currently securing web services, mail server service, and other services using these certificates. And since this solution is free, open source, and does not require any purchasing, it's cost effective because several years it's that we are free from buying commercial certificates, which we were doing in previous years. And we continue to improve this system, to extend it, because there are some ideas to provide more redundancy and so on. Here also I can describe that we have a renewal mechanism working at the central server, and renewal tool currently runs once a week, and it processes all certificates on central server, checks if they need an update, and after that clients run their tool to get certificates from central server, as I said, and report on each running tool on clients and or central server is being sent via email. So I will present on the next slide the examples. For example, here at the left, you can see the report or some part of the report that is being sent from central server. For example, here is the processing of some wildcard certificate and checking if it requires an update. And wildcard.yeghisabet.am certificate currently requires an upgrade, as we see, because it is valid. It doesn't require, sorry, the upgrade because it's valid until December 4. But another certificate, wildcard flib.sci.am, requires renewal because it's valid till October 23. And the tool checks that certificate will not expire in less than 30 days. It means that, as I said, we have 3 months for validity for the certificate, but the tools does not wait for 3 months. Even if 2 months has passed, it updates and gets fresh certificates. And here we can see that the process of renewing is being done, and the final done means that the certificate was updated. At the right part, you also can see the report that is being sent by a specific client when they get certificate. For example, a DROM certificate, wildcard certificate, is being requested, and here at the top right, you can see that this is output of rsync remote synchronization command, which shows that some files have been modified. It means that files on the client were old and files on central server were new, and they were updated. After updating the files on the client, also the tool or client checks if this certificate started on the service. For example, here we have a web server Apache, and first we check the validity locally as a file. So we know that certificate is finally some file. We check the file, and checking validity at file says that it's okay. It's, for example, for October 2. This is, in fact, a rather old report. And after that, also check is being done for connecting to the port of the service. So you can see it right below that the tool connects to Apache service port 443 and checks really if the service provides the up-to-date certificate. And we see that here it says that it's for some period. So as I said, it's rather old report, so dates may be old. But the principle is remains the same. So we have periodical reports both on the central server and on clients that they are updating, and they provide the new and updated information certificates. That's all. Thank you. And if you have questions, I'm ready to answer.
Если можно, я один вопрос задам. Вопрос такой. Вот я посмотрел внимательно на ваш лог. У вас сертификаты класса PEM, PEM. Они, система работает с сертификатом PFX? Майкрософтовские сертификаты. Майкрософтовские certification authority, когда они вырабатывают, PFX вырабатывает.
Честно говоря, для меня это незнакомо.
Назад по слайду пойдем, если увидите.
Нет, я говорю, незнакомо мне PFX стандарт, и здесь речь идет... PEM — это всего лишь расширение файла.
Я знаю, вот я поэтому...
Файл можно назвать как хотим. Речь идет о том, чтобы... Нет, в Linux будет все работать. Как хотим, можно CRT можно назвать, что хотим, можем назвать. Что?
Допилить можно, то есть.
Нет, в Linux ты всего лишь в сервисе каком-то, допустим, в Apache ты говоришь, как называется файл, и имя файла даешь, а уже важна внутренность. То есть имя extension тут вообще не играет роли абсолютно, но то, что вы говорите, речь идет о формате сертификата. Вот формат сертификата, скорее всего, он, естественно, отличается, если там речь идет о майкрософтовских, но я лично не знаком с этим. То есть у нас здесь речь идет именно о сертификатах, то есть это на самом деле public-private key. То есть именно вот то, что начинается begin и end, begin сертификат, вот это все записано в какой-то текстовый файл. А какое расширение дашь этому файлу, можно вообще расширение не давать. И в Linux, в принципе, это все спокойно пройдет.
Еще один вопрос, если можно. Максимально поддерживают ваш сертификат там 15625-битную длину? Можно сгенерировать такой сертификат? Не генерать KRSL, там какой у вас, и выставить длину, а сам сервис поддерживает там 15 тысяч битную длину? Ну не 4000, там 96, 8048, а именно 15 тысяч.
Я не знаю, это интересный вопрос.
Это равносильно AES-256, потому что я поэтому...
Да, я понимаю, такого размера я не пробовал, мы не рассматривали, но интересно.
Я на Raspberry пробовал, она умерла, так скажем.
Ну, это надо экспериментировать.
Опять экспериментировать. Благодарю.
Спасибо.
Ես կուզեի մի հարց տալ կամ ավելի շուտ մի փոքրիկ բան ասել, բայց ես կուզեի նաև օգտված լինել առիթից, նաև բարձել իմ անգլերեն վաղես զեկուցումը։ Let me to speak English. Yeah.
Welcome.
Yeah. I am a medical doctor, pathologist of large spectrum from molecules to human organisms. My name is Tigran Gevonzian. Now I am working in the Institute of Physiology, and why I am here, yeah, and here all lectures because I see the problem of the future, very, very big problem of the future, the problem of security of information transfer. Is important today, but it will get much more importance in the coming future. And I think this future is not so far. In the future, we will have super brains or four-seed brains with chips, which will receive new information also through simple transfer. And I think now and in the future must be very strong security of transferring the information to protect the people, to protect the supermans from crime, very clever crime. Therefore, I am here in order to be a little bit familiar with your words, phrases, sentences, and to understand a little bit. Thank you.
Thank you very much for your comment, for interesting thoughts. I agree, of course, that security is a very demanded topic, but it is very deep area, I can say, because there are many layers, many parts of security, and maybe you can secure your connection, but your end device will be not secured, and it will not help to have a secure connection if someone has access to the device where the data is stored. Because that's why it's not a question of connection only.
Yes, of course. It is a very complex problem, and
Yes.
Many specialists from many fields must be connected to work together.
Yes.
Thank
you very much. If there are no questions, I can move at our last presentation. I will try to present it much quicker because we have short of time. This paper is about implementation of load balancing for distributed video conferencing system. And we are talking about the situation we have met recent years because of COVID-19 pandemic, because it's changed situation and really there was a huge demand for online meeting tools. And all we understand that currently we are using for this conference the Zoom tool, and it's one of tools that are used widely, and other online meeting tools are also widely used because many people are not able to physically be present somewhere. And also we here in Armenia, in our network, Aslanyan, we started since last year rapidly responding to the increased demand for online meeting tools and for conferencing tools. And we have implemented the video conferencing and distant learning system. We had several systems, but we tried to improve and to implement better. And this paper is about that. Our current system we are using is called meet.asnet.am. It's based on open source Big Blue Button solution. It's a free system, but we have modified, we have implemented it for our use, and that is what is this paper about. Main goal of implementing this system was having on-premises local system and having our own platform to have locally managed and physically located within our country service. And by this service, we have provided and assisted many organizations to implement their different online meetings during this year and about 2 years. This service is web browser based, so it means it does not require client software to be installed. And although, as I said, the Big Blue Button separately is just a server with web page, and you connect to that and you can open some room and have an online meeting. But there are some limitations. For example, by default, it's up to 150 users that can connect simultaneously on that system. And you can, of course, have separate different servers as it's presented on the slide at the right. But instead of just multiplying number of servers, we implemented more flexible solution. Just what we did is having some single load balancer and connecting it to multiple servers. And when a request comes to load balancer, it looks where is the least congested, least loaded server, and opens a new session, new room at that server. So work balance is being provided by this solution, but also when you have multiple servers, you have another task of having recordings of session at some one single place. And in our system, we have implemented a centralized storage of meeting recordings. So it doesn't important which server serves you. If you connect on first or second or another server, your meeting recordings always will be stored in single place. And also in the system, we have implemented a load monitoring, as you can see at the right bottom part of the slide. The monitoring shows the load of each server, and this configuration provides possibility to flexibly add some server or remove some server at any time. And even if at some server we have some, for example, electricity power problem or power loss or connection loss, we can just ask people to reconnect, and they will automatically connect with the same address, but physically at another server. So the same room will act by the load balancer, will be redirected to another working server. This is a picture of more detailed implementation. And as I described, our goal was to have locally managed, physically located in our country service, because we understand that we can't compete with many other huge services, like, for example, Zoom, because they provide many other features and availability in different countries, availability of many servers. But our goal was another, to have our own system, and we have provided, it proved effective because many organizations used this system during this month to organize online meetings. That's all about this work, and if there are any questions, welcome.
It is not question, it is a remark. Yeah, remark. I want to share my experience. During the last 10 years, I went to congresses for my personal money. In the last year, I didn't go anywhere, and I didn't take part in virtual conferences because I have such opinion that it is not serious. But in this year, it is already the third virtual conference, and at 8 October, I will take part in other from Belarus, another conference. Recently, a week ago, I has said in the Yeghisabet of our institute that COVID-19 bring us two very positive things. First of all is virtual conferences, which allows two things to take part. Many people. This is already information exchange, very large information exchange, and we spend money. I spent my personal money because I don't go, but somebody is against this, and these persons are those who are directors and administration. They, face to face is better, is good, but for which money? For government, for state money. And state money. And second positive thing is this: masks. I have used the masks, these masks, even in 2019, yeah, before COVID-19, because I underwent operation. Because I underwent operation to remove some things from nose, and I make a joke in order to make free space for brain. Yeah. Now I don't know what is the situation with brain, but I am very sensitive to cold because there is only thin bone separation, brain and nose cavity. Yeah, nose, and I cannot breathe cold air. Therefore, I have used the mask before COVID, just in late evenings. Winter was very cold. And I have noticed that I am more stable to other viruses, grippe, nasmor, saretsum, and so weiter. And I think that in last year and in this year, less people will be ill from rhinopharyngeal cooling. This is the second positive thing. Thank you very much. And you are on the right way to save the money of the state. And this money must go to army, to building new roads. And thank you very much. And I wish very big success in this way.
Thank you for your comments. If others also wish to say something, we are close to finish. And I think it's good that we have done already, but of course we have a little bit late, but not so much.
I think if there is or there are no any question or suggestions, maybe I think we can close this session.
Have a nice meeting. Have a nice evening.
Yeah. Okay.
Thank you to all participants. Thank you, and we invite you to join us tomorrow.
Thank you.
Okay. Bye.
Goodbye.
Goodbye, everyone.
Bye to all. We will close the Zoom meeting now.
Thanks.